Welcome to HashiTalks Build Day 2.
Exciting.
I am super excited to see so many people join us for Day 2. If you've been here yesterday, you know what I'm about to say. If you've been here to one of the other HashiTalks, you will definitely have heard this before. But if not, you're joining a series that's global, themed, and regional live streams, organized by the HashiCorp community team, Rosemary, myself, Alexandra, Jasmine, and lots of other folks. And for us, this is an event where we support practitioners around the world, and we use it to amplify voices within the community. Today, we've got a themed event, which are always produced in English. And the idea here is today's theme and yesterday's theme is, let's talk about building. Let's talk about building cool stuff, either with our tools or with the wider ecosystem that HashiCorp enables. And let's learn from each other. We're live on YouTube. You might be joining us on LinkedIn as well. I think we're also on Twitch. If you're here, just say hi in the chat. Let us know where you're calling in from. Yes, definitely calling in. I think I just aged myself. I'm so sorry.
You definitely did. Yeah. No, put a comment in where you're from. We are excited to have you here. If you have questions during the process, please do put them in the chat or in the comments, whether you're on YouTube or LinkedIn. We love hearing from you. But if you do have questions or comments, do keep in mind we have a code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, and be professional. You can review our code of conduct at HashiCorp.com/community guidelines.
Be the kind of person that you always aspire to be, and everything will be cool. With that, let's get started. Rosemary, do you want to introduce yourself real quick?
Sure. I'm Rosemary Wong. I'm a developer advocate at HashiCorp. I talk about a lot of things, but some of my favorite things to talk about are Console, Vault, Terraform, Boundary, and a little bit more of everything else in the ecosystem. What about you, Karim?
My name is Karim Satili, also a developer advocate at HashiCorp, and I love talking about Packer, Terraform, Vagrant, and of course Nomad. And with that, I think let's do a quick overview of the day. While we have more people joining us from literally all around the world, I'm loving it. Hello everyone, also Alfonso, a special shout out to you from the Netherlands, love it. Right now I'm in Amsterdam, so this is great. We're going to be kicking off with Rotem in about 2 minutes. Then next up, we've got talks on the AWS Terraform Provider. Really cool session. We've got a special giveaway and a reveal of yesterday's winners, I should say. We're going to be talking about TFX, a standalone CLI for Terraform Enterprise and Terraform Cloud that enables a couple of cool workflows. I'm super excited about this one. We've got a machine learning talk on how to do machine learning using Nomad. Justin is going to be talking about how to contribute to Terraform providers, the do's and don'ts. I think next up, testing with Terraform, and also what to think about when you're developing with Terraform and actually developing Terraform.
Yeah. I'm impressed that there's a building security as part of this too.
It's important. It is all very, very important. And stay tuned for the whole stream because we've got a couple of special announcements, a couple of things that we want to highlight, and usually just a good opportunity for you to ask questions. Drop them in the chat. We'll ask them to our speakers. Some of them will join us in the chat, so you'll get live answers to your questions. And I think with that, we're going to hand it over to Rotem to talk about Atlas and an HCL-based language for database schemas. Excited for this one. Some slight technical troubles there. Rosemary, you're also on mute. So,
I know. Really, you know what? What's a day 2 getting started without having some technical troubles? Honestly.
we should have had the professionals from yesterday here. Cole did an amazing job getting all of this set up and working. While we're fixing this in the background, in the chat, don't just tell us where you're from. Tell us what your favorite product is and what you're building with it right now.
Yeah.
And what you're looking to build.
Oh, I know. It's been pretty fun. Oh.
Hi everyone, my name is Rotem and welcome to my talk about the Atlas DDL, an HCL-based language for database schemas. So a bit about myself. I'm the CTO and co-founder of a company called Ariga. I'm co-maintainer of 2 large open source projects. One of them is Ant, a Linux Foundation-backed ORM for Go. And the other one, which I'm going to talk about today, is Atlas. Atlas is an open source schema migration tool. It's been sometimes called by people in our community a Terraform for databases. And in this talk, I hope by the end of it, you understand why. Before we go into the ins and outs of Atlas, what it does and why, I think it's worthwhile to take a look, zoom out, take a look at how our industries evolved and changed with regards to managing databases. So once upon a time, we were talking about a single database. Today, we're talking about many databases per organization. Sometimes a single team or a single service might manage multiple different databases. In the past, going down, taking our application down for maintenance was an acceptable practice. Today, we are expected to build highly available application. This is the baseline expectation, always on. Finally, and maybe most importantly, in the past, the database was managed by the DBA or the DBA team. Engineers, professionally trained in how to manage these complex beasts that are known as databases. Today, teams are expected to be autonomous and to own their own infrastructure, to manage their own databases. Even in some organizations that do have DBA teams, it's not a reasonable expectation to think that a professional DBA would review, plan, approve every change to the database. If we expect teams to manage their own databases, we need to give them good tools to do this, because many engineers may be great in many things, but they're not necessarily super experienced and knowledgeable when it comes to managing databases. So when Ariel and Ariel is my co-founder, started working on Atlas, we started to look for inspiration of what kind of tool and what kind of experience we can give developers and software engineers and operators that need to manage databases today. Having experienced firsthand the revolution that Terraform brought into our world, to see our world as infrastructure engineers go from a big ball of mud of scripts and ClickOps and tools to kind of be unified by this one paradigm of infrastructure as code, a holistic and automated way of describing our infrastructure. We really wanted to bring this experience and this concept that developers expect today to the space of database schema management. Many tools exist today for managing database changes, called database migrations. But what's the difference between what engineers have come to love and expect from tools like Terraform and the existing generation of database migration tools? So the commonly cited reason of why Terraform and infrastructure as code is so great is this declarative API. You don't tell your tool exactly what to do, but you tell, this is the desired state. I want an S3 bucket in some region. And you run Terraform apply, and the tool you use then goes to inspect reality, sees what we expect from it, and tries to reconcile the difference between the two. When it comes to database changes, the way databases are managed is that they expect it to issue DDL commands, statements like create table users, alter table customers, that are not declarative. There are commands that need to be executed in some point in time. Many of them are not idempotent, so you cannot run them again and again like you do with Terraform apply. This means that the onus of planning and creating the plan is put on the developer instead of the tool they use. Now, in a small toy example like this, it does not matter. But when you are looking at real life database schemas that have hundreds of tables and thousands of columns and indexes, when you're trying to plan some change, the calculation that you need to make is obviously much more complex and more error prone. Aside from being complex and sometimes annoying, making schema changes does require a certain level of domain expertise that not everybody is aware of. For example, if you have a table in SQLite and you want to change the default value on one of the columns, it's not a single step, but actually requires 4 different steps: creating the new table with a new default value, backfilling it with the existing data, dropping the old table, and only finally renaming it to the original name. We can now touch on one of the core concepts in Atlas, which is declarative migrations. How do we apply the declarative workflow we know from Terraform to the domain of database schema management? So the way this works is always starts with the desired schema. What do we want the database schema to look like? You can provide this to Atlas in various mechanisms called schema loaders, but today we're going to discuss mostly the Atlas data definition language, which you saw a short snippet of in the previous slide. Once we have the desired schema of the database, Atlas goes out and inspects the target database. It does this by making queries to the database's information schema tables to produce a similar graph of the desired state of the database. The next step is to create a diff, basically to compare the two schema graphs, the desired and the current states. Finally, Atlas takes this diff and creates an execution plan. The reason is that the order of actions matter. Before we can create a foreign key referencing some column, we must first create it. So Atlas applies different algorithms like topological sort to order the different changes that need to be applied on the database in a sensible order. With the introduction behind us, we can now get to the core of this talk, which is the Atlas DDL. You may ask yourself, why did we decide to create a new data definition language, a new way of defining database schemas, when databases have had their own way for doing that for decades now? And if you're worried about it, just know that you can still use plain SQL, create table statements when you define the desired state of your database in Atlas. But in this talk, we're exploring the Atlas DDL, and let's talk about our motivations or goals for a new configuration language. So first of all, it should be declarative. The existing DDLs for databases are basically imperative statements, as we've explained before. Create table. It does not describe the table, but it describes the operation that needs to be done to produce the table that we want. And we know that the tools that we like to work with and that are most convenient for us to use the declarative paradigm. Second, we think of database schemas as interconnected graphs. So the language should support a very native way of expressing references or connections between the different components of the graph, and we'll see some cool examples of this in a bit. Next, the language should be type safe. Nobody likes making mistakes. Nobody likes introducing bugs. But when your editor discovers your mistake before you even saved it, it's not so bad. So we wanted to build something that was going to be type safe from editor support to production, and was going to be really easy to use. Finally, we wanted the language to be dynamic, to have stuff like functions and data sources, to let people building systems on top of it create really robust emergent behavior from the building blocks that we provide. Now, if you've never tinkered with HCL, here's a brief explanation of how it works. So first of all, HCL, the HashiCorp configuration language, isn't exactly a language, but more like a toolkit for creating configuration languages. And in this example, in my personal blog, you can see how you can create a PCL, the pizza configuration language, for your pizza as code application. Of course, this example is a bit humoristic, but it tried to cover the process of working with HCL to create a configuration language similar to Terraform. Now, HCL is a Go library. So all the examples here are in Go. And the first thing you do when you start to build your configuration language is to define the types, the data structures that hold the information that users can configure in your language. In here, in our PCL, we have the order, we have a contact, and we have an address. Once we define these types, you can see the struct tags that give the HCL libraries more information about how to decode the actual configuration files. Once we have that, we can use one of two libraries, HCL Simple, which is, as the name says, really simple, and Go HCL, which is a bit more low level. And we can use it to now read our configuration file. When you are using the HCL Simple library, the call is as simple as doing decode file and giving it the path to your HCL file. As you can see in this test, we are able to decode our order into this data structure. Some of the cool things that you can do in HCL is to create static values. Static values allow us to find errors in when we decode the file and to enforce more strict API as an alternative to just using free-form strings. So in this example, we have the size, where we can use these identifiers to define the pizza size that we want, and the different available topics. To make the API more explicit, what we do is we need to provide the decode function and HCL eval context. Basically, we can load these different identifiers into the context and finally make them available as variables. Then, once we want to read our HCL document with these strict identifiers, we can just pass the context to the decode file function, and as you can see, it will be able to load these values into our structs. Next, another cool thing in HCL you can do is to define functions, right? And in this example, we define a for diners function that, given the amount of diners, can calculate how many pizzas we need. Now, based on the universally accepted heuristic that you should order 3 slices per diner and round up, we can now define this function using this syntax, and from that point on, it becomes available inside our configuration language documents. Okay, let's now continue with a demo of how this all actually works. In this pane, we can see the schema HCL document. This defines the desired state of the database. I'm using here the Atlas HCL VS Code extension that gives me stuff like syntax highlighting and code completion and linting, and it's just really convenient to use. In this bottom pane, I'm going to run once a second a short script that connects to a local MySQL container that I'm using as my target database. You can see it running here and basically print out its current database schema in plain SQL. And in this pane, I'm going to be typing my Atlas commands. Now, the first command I'm going to show is Atlas schema apply. This is the command for declarative migrations, very similar to what you may know already from Terraform. I'm using the env local flag. This is a reference to an environment that I defined in my project file, an environment called local. And when I run against this flag, I'm connected to this database. When I execute the command, it connects to the target database, compares between the desired and actual state, and produces this plan to create our users table. Once we accept this plan, we can see that it's created on the target database. Now let's see if we want to add a new column, for example. You can see that our editor warns us that this is a duplicate resource. Let's add a column called name and use the tiny text type for the column. Next, let's apply this schema on our database. We can see that Atlas suggests to alter the table to add a column name. Let's apply this. And as we can see, the column was created on the target database. Now, it's recommended to use mostly a primary key on the ID column of a table. So let's do that. We can reference the column directly with this syntax. And once we apply, we can see that Atlas suggests to add a primary key on the ID column. Let's do that. And once this happens, you can see that the primary key was indeed added to our table. One of the ways that declarative APIs simplify life for developers is that the order in which we write resources does not matter. Let's show an example. We have our existing users table, but let's say we are building a content management system and we now want to add a blog post table. Now, in an imperative API, like the current database's create table statement, we would first need to create the users table, and only then can we create the table that depends on it. In this example, we have our blog post table that has an author ID that is a reference, a foreign key to the users table. Now, in a declarative API, we should theoretically be able to take this table definition and to put it anywhere in the document, because as we said, in a declarative API, we calculate a diff. Let's see how this works. We now see that despite the fact that the blog post containing the foreign key is defined before the user table, Atlas has no problem to calculate this diff and create it in the proper way. Next, let's see some ways in which using HCL allows us to build a safer development experience. So let's see what happens if I make some small mistake, like a typo on the column type. If I'm using the Atlas HCL editor plugin, I will see this immediately as I'm typing. But even if I don't, and I try to use this, way before any query is executed against the database, see that Atlas will validate that the column type is legal. In addition, because Atlas actually builds a graph representation from the schema document, it's able to explicitly enforce that references are correct. So, for example, if I were to mistype the column name for my primary key, I would get this feedback from the editor, and if I were to ignore this feedback, I would still get it here when I try to apply the schema. Now, of course, if the editor is able to validate this, it also can help me with auto-completion, which improves the developer experience and velocity. So far, we've shown features of the Atlas DDL that kind of map one-to-one to database features. I want to show you some of the other things that you can do with Atlas DDL so you can get a feeling of how you can manage projects with it. So let's start with something very basic, which is input variables. Similar to Terraform, you can define in a schema an input variable that is part of this schema. So let's imagine that we are building a multi-tenant system. In this multi-tenant system, we have a single MySQL server for all of our users, but we maintain a separate name database, a separate schema for each of our users. So to do this, what we can do is, after defining our tenant variable, let's just, for readability, rename our schema block to tenant, and we can show how we can create a variable schema name. So if the schema block has a label of tenant, but each schema can get its name from the tenant variable. Okay. Now, when we are working in multi-schema mode, we need to make some minor modifications to our project configuration file. So I created a separate block, and basically the URL here is just different in that it doesn't connect to a specific database schema in our server. So once we have that configured, we have an input variable. This input variable is used by the schema for its name, and we changed our references to use the reference to this schema block. We can now start to manage our multi-tenant application. Now first, let's see what happens if we don't provide this input variable to our schema. We'll see that Atlas will complain that it's missing this value for the required variable tenant. Now we can always provide a default value. We are a Seinfeld fan, so we're going to use George and Jerry for our tenants, and we will see that now it wants to drop our existing example database and create a new database for George. To simplify things, and because we're not going to have a lot of room on our screen, I'm going to stop this this watch script and close this pane just so we have a bit more space to look at. So we've shown how we can use a default variable, and now let's show this setup where we manage a separate database for each user. So let's say we want to create the database for Jerry. We can pass the tenant variable to equal Jerry, and now we will see that it's going to drop our previous example database, create a database for Jerry, and create these qualified tables. Great. Now let's see what happens if we try to do the same for George. Okay, now this is a problem because in our multi-tenant system, it's going to be a very big problem if whenever we want to create a tenant for one of our users, we need to drop the schema for the others. So let's see how we can tackle that. One way to handle this situation where we don't want Atlas to drop the existing tenants when we create a new one is to use the same mechanism we used for defining variables on the schema file, but for the project file. The Atlas HCL file shares many of the same features that the schema files. You both use HCL, and here also we can define a variable named tenant, and its type would be string, and we can now define that in our multi-environment the context is always a specific schema which is provided by the tenant variable. So now when we run the same operation for George, we can create his database without destroying Jerry's. And if we run the same operation for Jerry, we see that Jerry's schema already exists and is already synced. But what if our setup is more complex and we want to maintain these tenant databases, not a one by one, but in a complete way? Let's show how we can use the Atlas DDL to do that. Okay, let's take this example one step further. We no longer want to provide our tenants one by one. Let's say we have some configuration file. Let's call it tenants.txt, and we have currently Jerry and George as the tenants of our system. Okay, now let's bring, similar to Terraform, we can define a locals block, and let's say that these will be, we will read them from a file. We'll split it by new line, and let's say we read this from this directory, tenants.txt. Next, also very much like Terraform, we added the feature for each blocks. So we're going to repeat this environment for every item in the tenants set. Next, we need to change the schema context to basically take the for each iterator value. And finally, our schema HCL still depends on a tenant variable, so we must provide this. Any extra attributes that we assign to the block are forwarded as input variables to the schema below. Now let's see. If everything works properly, we should see no errors, and we should see that both George and Jerry's schemas are synced with the desired schema. This object does not have attribute named tenants. Of course, this is a typo. Let's see now. Both schemas are synced and no changes to be made. Of course, no Seinfeld example would be complete without adding Elaine and Kramer. Let's create Elaine's database. And now we're good with Kramer. Everybody is synced. Now, I want to take this opportunity to show another final feature that you can use in the Atlas DDL, which is data sources. In a toy example like we showed, it may be fine to load the tenant list from a local text file. But in a more realistic scenario, you will probably want to do this with a database query or an API call. Atlas, the Atlas configuration file, Atlas HCL, supports data sources similar to what you may know from Terraform. So, for example, we have this SQL data source, which will run some query against a target database. You can see the query here. We're querying the information schema to get the list of named databases in our target database. And we're going to take the output of this query and replace it here. So we can use data.sql.tenants.values. Now, whenever we run schema apply, we retrieve the list of tenants from the live schemas in the database and not from a local file. So wrapping up, the Atlas DDL based on HCL was created to support a declarative, type-safe, and dynamic workflow for managing your database schema. It's all open source. You can find it on our GitHub repository. And of course, if you're interested in building your own HCL-based configuration language, feel free to reach out to us. We're happy to discuss it and share from our learnings. That's it. If you have any questions, feel free to ping me on Twitter. You're welcome to visit our documentation website and join our Discord server. I thank you a lot for your time and wish you a great rest of the conference. Goodbye.
See, this is how you kick this off, right?
Yeah, I've never heard of Atlas HCL before. Now I have to try it. I have a couple of demos that I could use.
100%. Rotem showed me a few demos when we were talking about this talk and what we could have in there, and it was just so mind-blowing because this is, if you've done database migrations, you probably built some shell scripts, you probably did some other stuff, all stuff that nobody's ever proud of, but we all know we need to have.
Yeah.
And now it just works. I also love the fact that the JetBrains extension is coming next week and that there's already a Visual Studio Code extension. I love all of this.
Yeah, I really enjoyed it, and I'll have to give it a try. Rotem's in the chat, so if anybody has additional questions, please drop a note in there. I'm sure many people will be happy to answer the questions or just comment on it. And speaking of many people, terrible transition, but HashiConf is going to take place October 10th to 12th this year in San Francisco, California. Registration is open. So visit hashiconf.com for more details. Registration's open for it. So if you want to meet a lot of people who are interested in HashiCorp tools, want to talk about all the interesting use cases people are doing with it, maybe they're extending HCL and they're not using any of the tools, but are using some obscure library that we have, and one of our tools is dependent on it, but we don't actually do anything, really unique with it. And someone decided that they're going to use it for something. It's a great opportunity for you to meet folks there and get more information about how you can build on some of the HashiCorp tools as well. There was a question in the chat that I wanted to acknowledge, which is, will this be available as recording? Yes. All of the talks today, as well as yesterday, are available, and they will be available online.
2 months to go till HashiConf. So if you haven't gotten your ticket yet, get on it. Get your flight ticket sorted, get your hotel sorted, get everything sorted. It's going to be amazing. Rosemary, you're speaking. What are you going to be talking about?
I am. We're going to be talking about developer platforms. And so what are the questions that you should be asking when you decide to invest in a developer platform? And they're going to be more along the lines of technical questions and challenges that you're going to encounter as you build out and grow your platform.
Nice. Learning from best practices is always nice because it gives you food for thought. Yeah. Come home after a conference, change everything up as you go into the holiday period. It's going to be amazing. Yeah. Before we do that, though, we've got a couple more sessions.
We do.
Next up?
Next up, we have a really fun one. I think, something Terraform providers are some of my favorites to talk about.
100%. For me, I think the biggest or the most interesting fact here is last year, November, just before re:Invent, we celebrated 1 billion downloads of the provider. And I just had to look it up because I was curious, how are we doing right now? We're at 1.9 billion. This is the single most downloaded provider for Terraform. And there's a lot of work that goes into maintaining the probably like 700 different resources. So if you're thinking about contributing to the AWS Terraform provider, Albert might have some hints and tricks and tips for you. Over to you.
Hello, and welcome to the Contributing to the AWS Terraform Provider session here at HashiTalks Build. My name is Albert Silva, and I am a Principal Cloud Architect at Amazon Web Services. The reason for this session is we want to introduce you to a brand new workshop that we built in collaboration with our partner, HashiCorp. And the goal of the workshop is to help contributors either get started in the process and or grow into maturity in the process in the case where you're already an experienced contributor. But before I get into the workshop, I want to talk a little bit about my own experience as a contributor in the hopes of maybe inspiring some or helping remove some doubts for some folks that may have thought about doing this before, but haven't found the confidence to do so. First and foremost, I'll say that I don't consider myself a developer. In other words, you don't have to be a developer to perform contributions. Back in the day, I did want to get into development, and I did some of the core courses with things like C and learned some of the basic programming constructs, such as if statements, loops, and things like that. But it got to the point where I felt I didn't want to be in front of a keyboard writing code all day, and I eventually ventured into the infrastructure side of things. Infrastructure was fun because I still wrote a little bit of code, some configurations for things such as like network switches, but I also got to be hands-on. I got to like stand in front of a rack, cable stuff, work in data centers, and I found that to be a little more enticing. Fortunately, as cloud came around, things kind of came full circle, where I could still work on some core infrastructure stuff, things like compute, storage, networking, but it's hard to do those things without dabbling in a little bit of code and development nowadays. So both of my worlds kind of came back together over time. With AWS specifically, I started picking up Python as a language. And again, with some basic constructs that I had learned back in the day, Python syntax isn't too hard to grasp. So that was a quick ramp up for me. And then I started learning about Boto3, which is our AWS library to interact with the AWS API in Python. I wrote a lot of scripts that help maintain environments and automate tasks, but eventually I had to get into something called CloudFormation Custom Resources. So I'll take a minute to explain what that is. Before getting into CloudFormation, for folks that haven't heard of this, or maybe you're brand new and you haven't even heard of Terraform, we have some tools out there called infrastructure as code tools. CloudFormation and Terraform both fall into this category. And it allows you to define your infrastructure as code. So imagine you need an EC2 instance, maybe you need an S3 bucket. Rather than logging into the console and clicking around and provisioning stuff, you can write a few lines of code saying, I want an S3 bucket, this is its name, this is its property, go apply. And that way you have a piece of code that describes your infrastructure that you can check into a repo, you can version it, you can have folks take a look at code review before doing a merge request. The benefits are really endless. And well, back in the day when I started in the AWS world, I learned CloudFormation because that is the tool that AWS offers out of the box. What I found was that in some cases, some new services still had no support for CloudFormation. And or maybe a service launched a new feature and that feature was still not supported in CloudFormation. So what do? I don't want to go to the console and provision that. So the workaround in the CloudFormation world was to create what we call a custom resource. And a custom resource is essentially a Lambda function that performs the action that you want it to perform. So being Lambda, any Lambda runtime such as Python, Node, Go is supported. We have AWS APIs for all those. And you would basically tell CloudFormation, hey, when I want to provision this new service or this new feature, go and call this Lambda, and this Lambda will do the job for you. Little did I know that some of the constructs that I was building in Lambda and in Python are very similar to the constructs that I ended up building over time as a contributor to the provider. So for those that are maybe a little more development savvy, you know what I mean by CRUD operations. CRUD stands for create, read, update, delete. And if you think about provisioning resources, right, these are operations that you're going to have to learn how to deal with in code. So when I was writing CloudFormation support, I had a function that said, hey, if a user wants to create this particular resource, what do I do? How do I go about creating this resource? Similarly, if user decided to perform an update to that resource, how do I handle that? Does that resource support an update to begin with? Do I need to recreate it? Can I do it in place? And the examples continue, right? Same thing if the user is tearing down the stack, how do I go about deprovisioning, deleting that resource? And I did this for a little while, and it went well. It was fun, I'm not going to lie. But over time, more and more of my customers started going down the path of using Terraform because of different benefits that we won't get into in this session, but it's become very popular. And similar to the challenges that we found in CloudFormation, when new services launch, when new features are added, that support is not always in the Terraform provider day one. So what is the equivalent of creating a custom resource in CloudFormation in the Terraform world? Well, the equivalent is doing a contribution or change into the public provider, the provider that the entire world, all AWS customers use, to support that. And that to me seemed pretty cool, right? Because I can now influence and I can make an impact, not just for my customer or my needs by writing a custom resource, but by contributing to this repository that everybody leverages and can benefit from. However, that's also scary at the beginning, right? In my case, I didn't have any kind of open source experience. So yes, I knew what GitHub was. I knew how to create and clone a repo, but when I looked at code in these public open source repositories, the provider included as well as some others, I would tell myself, this is code that's written by real developers, right? The clone is the code is so clean, it's succinct, it is efficient, and again, it becomes very evident I am not a developer. I don't do this all day. So that was a little scary at the beginning. Another thing I had to get over was, hey, the provider is written in Go. I don't know Go, or I didn't know Go. Again, basic constructs like ifs and while statements and loops still apply, but it is a new syntax nonetheless. And perhaps it's not as friendly as, syntax in Python, which is what I was doing. But nevertheless, I started ramping up on these things. I learned about open source contributions. I took a small course online on Go. Eventually, to be honest, what really helped was just diving into the repository code and starting to write stuff myself to see what my challenges were, what questions I had, and so on and so forth. And I started by contributing very small things, a couple of data sources here and there. I got some feedback from the maintainers as well as some of my coworkers as far as hey, you could have done this a little differently, or this is the right way of doing that. But while I did that, my confidence in contributing just grew and grew and grew, and I started tackling more and more difficult things. So instead of just doing a data source, well, let me add some functionality to a resource. And eventually, as brand new services that had no support, it wasn't about adding functionality anymore. It was about hey, Control Tower has APIs now. Let me go write some support for that. Or FSX has a file cache now. Let me go write some support for that. And obviously the skill set required was very different, but starting small and growing into it really helped me get there. All this, not to tell you a lot about me, but to really institute the fact that if I can do this, you can do this too. Yes, there is a little bit of a ramp up, but we feel that this workshop that we're talking about in this session is really going to help everybody, not just folks who are experienced open source contributors and or developers, to contribute back to the provider. Now, I keep using that word provider, and I realize that some folks may be familiar with Terraform, some folks may not. And again, the audience for this workshop is everybody. It doesn't matter how much experience you have or don't have. So I figured I'd take a step back for 1 second before jumping into the workshop itself to talk about what is it that I mean by Terraform Provider. So it turns out that Terraform has two parts. It has the core portion, and this is kind of like the brain. Like when you go on the HashiCorp website or you use your package manager like Brew and you install Terraform, this is what you are installing. You're installing the core. And this core is what interprets your infrastructure as code. In the case of Terraform, HCL. This is the portion that is responsible for doing things like execution plans and resource graphs. And what I mean by that is, let's say that you're deploying 10 different resources and some of them have dependencies on each other. How is it that Terraform figures out that I need to create X before I create Y? Well, all that logic is part of the Terraform core portion of the product. However, Terraform can't do anything with just the core. It needs this thing called providers to actually do anything. And the providers themselves are what interact with APIs. In the case of the AWS provider, the provider is the one interacting with the public API in the AWS world, but you can think of many other examples and vendors where this also holds true. It is the provider that has the smarts to deal with that particular vendor with its API to create resources as well as data sources that Terraform manages. And data sources, again, for those who are new, have the ability to basically perform a read operation and not just create a resource. And you can combine these together to do some really powerful things in Terraform. So with that out of the way, I wanted to talk about okay, let's say that you're excited, you're willing to do some contributions. What will look like? Well, first of all, you fork the AWS Terraform Provider repo. Again, if you're new, if you have no idea what I mean by fork, don't worry about it. The workshop covers this. Then you create a GitHub issue. And when you hear the word issue, maybe it sounds like, oh, there's a problem, there's a bug. But issues actually cover a whole lot more in GitHub. You can create an issue to say, hey, I want to add support for this service. Or perhaps you create an issue saying, this service has this new feature and I want to add support for it. And in some cases, it's just, hey, maybe this documentation needs a little bit of updating. So issues have multiple purposes. The main reason for creating a GitHub issue is because you want to make sure that somebody knows that you're about to develop and or fix something. Otherwise, you may have other folks that run into that same problem, and now you have two people working on the same thing in different parts of the world and duplicating efforts. So think of the issues as a central repository of, hey, what is being worked on for the provider right now? Once that issue is in place, you can start developing. That's the fun part. Hands on keyboard, you write your code, and once you've tested it and it works, you raise something called a pull request. And again, if you have no idea what that means, the workshop will get into it, but think of it as an ask to, hey, please incorporate my code into the main section so that other customers can leverage it. So this is very high level. And at this point, what I want to do is I want to actually dive into the workshop. There is a link here for contributing to the Terraform provider. And let's go ahead and take a look at what that looks like. This workshop is powered by AWS Workshop Studio, and it can be consumed in a couple of different manners. We're going to be running this at AWS events, where you can actually take some time out of your day, run this, and we'll give you an environment that's all ready to go for you to start coding. And or you can do it at home in a self-paced kind of manner. So I won't go through every section, but I wanted to give you a taste of what to expect here. First of all, we have our outcomes as far as what am I going to get out of this workshop? It makes it very clear that anybody interested can benefit. It is a 300 level workshop, but it does not mean you have to be 300 level to get started. Again, this is meant to take you from very beginning all the way to advanced if you choose so. We estimate about 8 hours, but that is going to greatly vary by different folks that take this. Some folks may be able to skip some sections altogether. Some folks may want to revisit some sections. But what's good about it is that every section kind of stands on its own. So if you wanted to do this section and then take a break for a week and come back the following week, you can get away with doing that and you won't lose any of the experience. Cost-wise, when you run this workshop as part of an event, it is an AWS provisioned account, and AWS takes care of those costs for you. When you do it on your own, there will be some charges incurred. And the reason for that is if you are developing a resource, well, you have to test it. And the only way you can test it is to deploy it. Granted, right after deploying it, you're going to delete it, so it's very short-lived. It's probably not going to cost a whole lot of money, but it is worth mentioning that it will incur some costs. We have some handy links here on the left-hand side. One of them is the actual repository for the AWS provider. We have the contributor guide, the API references, as well as the Go API references for version 1 and 2. As far as the actual workshop is concerned, we start at the very beginning. We talk about some of the things that I just talked about regarding, hey, what is the difference between Terraform Core and the Terraform provider? We also talk about a thing called Terraform states, and I'll take a break here for a moment just to talk about this for 30 seconds. When you provision something with infrastructure as code, we store the results of that provisioning in a file. In the case of Terraform, it's kind of like a JSON file where you have a list of resources and you save information. So let's say you created an EC2 instance, right? You would say, hey, what instance ID was created when I call this operation? Or maybe you want to say, what tags did I create with this instance, or what subnet does it live in? And what that allows you to do is, if you make a change and you go and you run Terraform again, Terraform can compare what it thinks it should be there, meaning what did I do last in my states, versus what is currently live on the AWS environment. And if it's the same, great. If it's not the same, it actually allows you to standardize what's in the environment with what's defined on your code. So your code kind of becomes the source of truth, and changes can be reverted and or applied in that manner. So the file that stores Terraform's knowledge of that resource is called the Terraform state, and we talk about it here in the workshop. We talk about the contribution process, like we just talked in a couple of slides ago, but we go into a lot more detail. So again, you may not be familiar with GitHub, so we have full screenshots and step-by-step instructions on how to create a fork, how to clone the repository, and how to create the issues I talked about. And if you take a look here, you can kind of see some of the different things that you can report that I was talking about earlier, right? You can, yes, definitely report a bug, but you can request an enhancement, or you can request a new resource, or in some cases, hey, maybe it's a new region, who knows? And we guide you through, let's say you're requesting an AWS backup plan resource. How do I fill out that form? Step by step. And I wanted to call out this last question here, because at the end of the form, it asks you, would you like to implement a fix? And if you're an experienced contributor and you're comfortable, I totally encourage you to say yes. By all means, go and implement that fix. But let's say that you just got started and maybe you're comfortable creating data sources, but you have a need to add a feature to a resource or a brand new resource, right? Don't let that stop you from creating an issue. You can still create an issue and you can say, no, I won't like to implement a fix. But it gives the community visibility for, hey, this is something that has to be addressed and developed at some point. And hopefully somebody will pick up that issue and help develop that feature for you. We go through the development overview, and I'll talk about it here without going into the weeds. But essentially, you create a branch, basically think of it like a dedicated workspace for a particular feature that you're working on. And if you're working on multiple features, you would have multiple branches that you can change between them. And then you would create the resource and or data source. So that's the actual file and code that backs that particular object. The repository and the provider brings a tool called Scaf, which provides scaffolding to kind of like lay out the basics for you to kind of like plug and play. So we talk about this and we give you instructions on how to leverage it if you choose to. You then fill out the resource schema. So what is a schema? Well, let's say that, once again, you're creating an EC2 instance. That instance is going to have properties. For example, what AMI ID am I going to leverage? What subnet am I living in? What VPC security groups am I applying to it? So these attributes all form part of the schema, and you'll see an example of that earlier. We have the implement CRUD handlers. So like I spoke about, create, read, update, delete operations. You're writing the logic to back all these operations as part of your code. Once you get that working, we write something called acceptance tests. And I'll be totally honest, in some cases it takes longer to write the test than it does to write the actual resource or data source. But tests are extremely important. Number one, it gives you as a contributor the confidence that your code is working. Secondly, it gives HashiCorp, the person looking at your request, so please include this into the customer base code, right? The confidence that the code you wrote works and that we're just not including faulty code in the provider. But most importantly, let's say you write a new resource and maybe 6 months from now a new feature comes out and another contributor decides, hey, I'm going to go add this feature. Well, by running the acceptance test that you wrote 6 months ago, it also gives that contributor confidence that they didn't break your original code, hence not breaking all the customers that may be leveraging it at that point in time. So acceptance tests are very important, and they're a key part of contributing to a provider. You also get to write documentation. So if you've ever used Terraform registry, where you look up a resource and you say, hey, like, what attributes am I defining as part of this resource, or what am I getting back? Well, all that documentation is written by contributors like yourself. So when you write a new resource and or you add an enhancement, it is your responsibility to go ahead and update that documentation and include it as part of your change. You'll run some local tests and checks, which include acceptance testing, but also some linters to make sure that your markdown is formatted properly, that your Go code is written to best practices. And if all that passes, then you create a change log saying this is what I'm changing, and you raise a pull request. Again, we include all the instructions needed here for you to create that pull request. And then we wait for the maintainers of the AWS provider to review it and eventually merge it back for all customers to benefit. The bigger section here is probably this development process. And again, we won't jump into the weeds on this session, but it goes into detail as to like, hey, how do I use this scaffolding tool? Step by step, with screenshots to make sure that you can get through it. It shows you how to fill out the resource schema. So again, those properties such as, hey, my AMI ID, my name, my subnets. And it gives you examples of what that actually looks like in code. And even shows you what a sample schema for an existing resource looks like. For those that are current contributors and may want to stay up to date or challenge themselves, we also have documentation on using the new Terraform plugin SDK, which is a more advanced way of writing resources and eventually is the future of the provider. So I encourage all current contributors as well as new ones to take a look at this section and see what changes are present in the provider and how maybe you can leverage them in future contributions. We go through how to implement those CRUD handlers, and we even provide some samples with comments so you know exactly what's going on every step of the way for each operation. We go through the writing of acceptance tests, what they look like, how to run them. We go through running those linters for markdown and formatting and things like that. And then once you have all of this at least present, as far as like, hey, this is what I need to do, we provide some hands-on development exercises that you can choose to do if you're a new developer, or if you want to jump straight into developing a resource or a data source for a need that brought you to this workshop to begin with, feel free to do that as well. But if you go into this section, you'll find that we take you through data source development first. Most folks will say that's the easiest. And we take you through a 100 level exercise, meaning let's just add a little bit to an existing one. And then we step it up a notch and say, hey, let's create one from scratch, which would be more of a 200 level thing. Similarly, we do the same thing for resource development, where we do a 100 level, hey, let's add functionality to an existing resource. And then we bump it up a notch and say, okay, now we're going to create one from scratch. That one's more of a 300 level thing. We do the same thing for acceptance testing, where you can write a test for a data source, for a resource, and we always provide a check your work section here, which is kind of neat because you write your code and you have kind of like a point of reference of like, hey, was it right? Did I miss anything? You can always do kind of like a stare and compare. So this is the contributing to the AWS provider workshop in a nutshell. We think it's going to be very helpful and very beneficial to customers, contributors, and we're excited to hear what the community thinks about this. I appreciate the time that you folks have given me today, and I look forward.
Sometimes it happens that we lose like the last 30 seconds because I guess wrong buttons get pressed.
I know, right?
Testing in production is the only way to make things like this happen. So don't do that. What you should do though is, I think, as we learned in this session, sometimes it does take longer to write the tests than to write the actual resources. That's a good thing. So definitely write the tests. Spend time on writing the tests instead of testing in production.
Yeah. Well, it's a, I think it's important, but also, first of all, yes, thank you to the AWS Terraform Provider team for organizing such amazing documentation or contribution, and for emphasizing testing, because tests are the way that someone else knows what to do with your code. So they're very important. I appreciate just the amount of detail that went into those documents.
Albert absolutely killed it in the best possible way. Great workshop. Definitely check it out. This was great. Houston, we've got a winner. Let's talk about that.
Why did you choose that?
I've been waiting for this for the past hour to say it. So I'm super excited to announce that we do indeed have a winner for yesterday's HashiConf ticket giveaway. Sydney Henderson from Houston. Congratulations. If you're watching right now, please stand by your phone, which will not ring, but we'll send you an email. You won a pass to HashiConf.
Yeah, very exciting. We're excited. If you are able to go, we hope to see you there. So do let us know.
Yes, definitely come say hi, and definitely reference this moment. Let's get a selfie. Show people that that this is actually a real thing.
Yeah.
We also have 3 discounted passes. We'll reach out to those winners as well. I'm excited about that. And we're giving away 1 more pass today. 1 more pass and 3 discounted passes to HashiConf. October 10th through 12th, San Francisco. But how do we win?
Oh, yeah. So if you may have noticed, go to hashi.co/build giveaway. If you fill out that form, you'll have a chance to win a pass to HashiConf. If not the pass itself, you get a discounted pass, one of the 3 discounted passes. Do visit that URL. Let us know what you're looking forward to at HashiConf. And we require a HashiTalks build registration. That way we can get in touch with you and let you know that you, like Sydney, have won a pass. But if you have won a pass, we will be in touch, and we'll have some more details on how you can redeem those.
Offer only valid where applicable by law, of course. Also, other important things. Who's our next speaker?
Oh, well, we talked about the AWS Terraform Provider team, but we also have, more folks who are talking about, AWS and Terraform, which is pretty exciting. And I love working with these folks. Shout out to them in chat. I think Welly might be in there still, hopefully. Welly and Glenn are going to be up next. They're going to be talking about testing for backward compatibility when developing the Terraform AWS Provider resources. So more testing. I'm excited for that.
Me too. This is going to be great. And before we switch over, I just saw Alessandro Romano reply in the chat and say congrats to Sydney. Alessandro, congrats to you too, because you won one of the discounted passes.
Yeah. Wow. I can't believe it. Someone was in the chat watching for day 2.
Love it.
I know. Okay. We were waiting for someone. All right. with that, we're going to turn it over to Welly and Glenn to tell us a little bit more about the Terraform AWS provider.
Hello everyone, thank you for joining us today for HashiTalks Builds. Today, we'll be talking about backward compatibility when developing AWS provider resources. How can we test for backward compatibility when contributing to the open source AWS provider? And we'll also cover how to ensure backward compatibility when new features and new arguments are released and we want to support it in the AWS provider. So I'm Glenn, I'm a cloud architect at AWS, and I've been contributing to the Terraform provider for a while now, and I find it very fulfilling, and I'm happy to share with you some of the observations I've made when coding for backward compatibility, and hopefully you can apply this to your development and contributions towards the provider as well. So let's dive right in. So this is an overview of what we're covering today. First, we'll run through the basics, how the Terraform registry relates to what we see in the GitHub repository, as well as the API documentation. Next, we'll go through the background of the specific task, and this task is used as an example of how we introduce a new argument to an existing resource and ensure backward compatibility. We'll talk about some of the challenges faced when coding for this particular task, as well as solutions to these challenges, and how these solutions ensure that there's backward compatibility for the various arguments that are introduced. Next, we'll test for backward compatibility. That involves listing out the various test cases, putting ourselves in the shoes of practitioners to see how they might use the resource, and test for the different use cases. Finally, we'll talk about how we document these changes to ensure that practitioners know what are deprecated arguments and what are the new arguments that they should be using, as well as what are the new arguments that are related to the new feature releases. So let's dive right in. So the first is the Terraform registry and the provider. So over here, I've taken a screenshot of the EC2 instance resource from the Terraform registry. We can see that it supports an argument called enclave options. And this is actually defined as a single block in Terraform that supports one argument. So on the right, you can see enclave options over here. And this is defined as a block below that supports the enabled argument that can be set to either true or false. And I've added a link to the registry over here as well. So how does that look like behind the scenes in the repository? So in the Terraform provider code base, similarly, we see enclave options over here. It's defined as a type list with max item of 1 since it's going to be a single block. It supports the enabled argument, and this is a boolean that can be set to either true or false. And again, this is linked over here. You can click on it to see the full definition of the resource in the GitHub repository. So let's also take a look at the AWS API documentation to see how it relates to how the schema was defined over here in the repository. So in the AWS API documentation, similarly, we're looking at the enclave options argument. So for example, this argument has a type of enclave options request. And then let's take a look at that object. So within that object, it again supports enable, and it can be set to either true or false. And I've linked the documentation here as well. So we can see that this relates to the schema where one enclave option support a single argument. That's what we see in the code schema, and we also see that specified in the registry. So typically the code would follow what we see in the API documentation as closely as possible. So let's go over the background of this particular task where we are going to introduce a new argument to the same resource. So this particular argument comes from this new feature release. So you can see as of April 28, 2023, Amazon EC2 now supports AMD Ceph SMP. So this is the release announcement. I've linked it over here. And let's look at the API reference. So there is a run instances CPU options argument. So within the API of run instances, which creates the EC2 instance, it supports a CPU options argument, and this has a CPU options request object. Within that object, it supports 3 arguments, EMD, Ceph, SMP, that can be set to either enable or disable. And we can see that there's core count and threads per core as well. So these are 3 arguments supported under the CPU options. So this is a bit of the background. We're trying to add this AMD Ceph SMP to the for this particular AWS _instance resource. So some of the challenges faced for this particular edition was backward compatibility, and we wanted to ensure that whatever we're adding would not result in unexpected terminations for practitioners, because all these arguments must be specified at create time. As of today, there's no update API for them, so we have to be extra careful when coding this particular new feature. So we can see this is the existing provider schema. It defines CPU core count and CPU threads per core outside of a CPU options block. So this deviates slightly from the usual convention where we follow the AWS API documentation as closely as possible. So these are the two arguments that potentially should be deprecated and moved over to the CPU options block. So let's look at solution number 1 that does exactly that. So solution number 1, we introduce the CPU options block. Similar to the enclave options block, we define it as a type list with max item of 1. Within that block, we support the core count and the threads per core argument as seen from the AWS API documentation. And over here, we specify a conflicts with, and we conflict with the older arguments of CPU underscore core count and CPU underscore threads underscore per core. So we conflict with this so that practitioners can only use either one of the old or the new arguments that we've just introduced. So next, let's go back to the previous arguments. And now since we have introduced new arguments, we want to deprecate these old arguments. So you can see we've introduced a deprecation notice over here to prompt practitioners to use the CPU options block instead. And similarly, we also specify the conflicts with. So practitioners should only be either using the newer arguments, and they should be using the newer arguments, or using the older arguments. They should not use both at the same time, and we will throw an error if we encounter such a case. So that is the solution to challenge number 1. So challenge number 2. So challenge number 2 is allowing argument specification without terminating EC2 instances. So what do I mean by that? So in this screenshot here, we can see on the left, maybe a practitioner has defined a CPU options block without specifying AMD Ceph SMP. So that value, it's now empty. And then after that, they decided to apply, and now they explicitly specify AMD Ceph SMP to disable. Now for some background, by default for EC2 instances, this argument is set to disable. So if as a practitioner, if I set the argument explicitly to disable, after in the second apply, when the first apply I haven't specified it, I wouldn't expect the EC2 instance to be recreated. I would expect no changes detected. So back to our CPU options block, we can see that we also have a AMD Ceph SMP supported argument over here. And here we introduce a diff suppress function. And what this does is it first checks whether the ID is not equal to an empty string. So what this means is checking whether the EC2 instance is a newly created instance or an existing one. So we want to check for an existing EC2 instance. So next, it also checks what are the old values for the AMD Ceph SMP and the new value. If the old value is an empty string, meaning that the practitioner has not specified AMD Ceph SMP, and then suddenly in the new value specified it as disabled, we want to suppress the diffs, hence we return a value of true. In other scenarios, for example, if practitioners did not specify AMD Ceph SMP, and then suddenly specified it but set it to enable, we will want it to not suppress the diff. We want the diff to actually happen, which should then force a new EC2 instance to be created, which terminates the old one and creates a new one. Hence, you can see that there's a false new over here because there is no update API as of today. So with all the backward compatible changes in place, let's look at how can we test and validate our changes are correct. So the first step, let's look at the CPU options block. So for the CPU options block, we want to test that the deprecated arguments still work, because usually deprecations don't happen within the minor version. They happen in the transition to the next major version. And then we also want to test for you practitioners who are now on the deprecated arguments, can they migrate over to the new arguments safely without having EC2 instance terminations. So you can see the test cases listed out over here. First one, we want to test that the existing deprecated arguments still work. The second test case, we want to test that the new CPU options block still works with the core count and threads per core, which are the newly introduced arguments, to replace the deprecated arguments. The third one is interesting, but we want to transition from the deprecated arguments to the new CPU options block, and we will expect no EC2 instance recreation. Next, we want to test a bit more robustly, where we test the CPU options block without specifying core count and threads per core. This means that it'll be its default values. And then we expect no recreation when now practitioners specify the core count and threads per core with the default values because nothing has changed. We want to test that scenario as well. And finally, we want to test the new CPU options block with core count and threads per core only without AMD Ceph SMP to ensure that it still works as expected. So let's zoom in on the third test case over here. So in the third test case, an example you can see is on the left. So on the left, the practitioner is using the deprecated arguments, which is the CPU core count and CPU threads per core, and has set it to values of 2 for both. On the right, now the practitioner decides to migrate over to the newly introduced block, the CPU options block. So they define the block and they specify core count and threads per core also with values of 2. In this case, they would not expect any EC2 terminations. So when we migrate there, again, in the codified test case, we would test that the EC2 instance is not recreated, and we do that by checking its ID. Its ID shouldn't change across multiple Terraform applies in this particular situation. So this is just one of the interesting test cases for testing of transitions between deprecated arguments to new arguments. Next, let's go over the test scenarios for the new AMD Ceph SMP argument that is part of the CPU options block. So the first two test cases are rather straightforward. We just test what happens when it's enabled at create time and then updated to disabled. In this case, we expect recreation because as of today, there's no update API for AMD Ceph SMP. It must be specified at create time. So similarly, we test the other way, where AMD Ceph SMP is set to disable and then updated to enable. Again, we expect recreation. Next, we want to test CPU options with all three arguments now: AMD Ceph SMP, core count, and threads per core. That should work. Next, we want to test practitioners without a CPU options block and then update it in the next Terraform apply. They have an update where they introduce a CPU options block with AMD Ceph SMP as enabled. Now, by default, AMD Ceph SMP is disabled on the first Terraform apply. So in the next one, when they explicitly specify it to enable, we expect recreation. Now, in the next test case, this is the interesting one. When on the first apply, practitioners specify the resource without the CPU options block. And now in the second apply, they specify the CPU options block with AMD Ceph SMP as disabled. In this case, since in the first apply, AMD Ceph SMP is by default disabled, we will expect no recreation. So let's see how these test cases can be codified. So the provider provides a very convenient function where we can just specify a command like the following. And this then starts the various test cases, as you can see over here. So we'll wait until all the test cases pass, as you can see, and then typically we will copy and paste this in the pull request that we make against the repository. So that brings our testing to a close. And now the next very important part still is documentation. So we want to inform practitioners who read the documentation at the Terraform registry on what arguments have been deprecated, what are some gotchas that they may have to take note of, as well as we want to introduce the new arguments to practitioners as well. So over here, we start with the basics. We want to introduce the new arguments. So here we introduce the new CPU options block, and we state that it supports the following three arguments as what we've seen in the API documentation: AMD Ceph SMP with the enabled and disabled valid values. We can specify core count, and we can specify threads per core. Next, we want to also set a warning that modifying any of these three arguments would cause a resource to be destroyed and recreated. So that is for practitioners who might want to update it so that they can read the documentation and are aware that any updates to these three arguments would cause a new EC2 instance to be recreated. So we can see also for the old arguments, we also want to set a deprecation notice. So for the CPU core count and the CPU threads per core, we specify it as deprecated, and we recommend that practitioners use the new CPU options argument instead. So with that, our documentation is completed, and we have seen how we can code in a backward compatible manner. We've seen how we can test those backward compatible changes, and finally document those changes. And that brings me to the end of HashiTalks. Thank you very much for taking the time to attend, and let me know if there are any questions. Thank you. Bye-bye.
Nice. I am very impressed by the level of detail and the nuance just to make an API update.
Right?
But it goes to show that a lot of what we take for granted when we use a provider is all of this logic and all of this testing when it comes to understanding how applying a change and how these things affect existing resources, non-existing resources, and everything else. It's nice that someone else tests it for you.
Yes. And it's not just a happy path. There's the happy path is always the easy part, right? It's the hard path, like, oh, you specified, 25 character resource name when 24 is allowed. How are you going to deal with that? You specified, last month's schema for the API versus this month's schema, which actually adds all those subkeys that you're thinking of. It's stuff like that is hard. Always love these short sessions. And of course, if you've just joined and if you're wondering, what was this session about? We'll have a recording for this available at a later time.
Yeah.
But before we get there, who's our next speaker?
Well, next we have Tom Straub, who's Terraform, I would say one of the Terraform experts that you should be paying attention to. I think that Tom has always provided some really amazing content for HashiTalks in general. Today, he's going to talk about TFX, a standalone CLI for Terraform Enterprise and Terraform Cloud. It's really interesting to hear about a CLI for it because we usually hear about a CLI for various other tools, Terraform included, but a specific CLI for enterprise and cloud is really interesting, right? Because it's a lot of API calls and a lot of things you want to do with it too. So I'm interested in hearing a little more.
Let's kick it over.
Hello, welcome to HashiTalks Build 2023. Today I'm going to talk to you about a tool that I developed called TFX. First, a little bit about me. My name is Tom Straub. I am a staff resident architect here at HashiCorp, which really just means that I work with some of our biggest customers, helping them deploy, adopt, and scale Terraform Enterprise within their organization. I've been using Terraform since the 0.6 days, and has earned me the nickname Terraform Tom. The rest is kind of history, as they say. And you can find me on LinkedIn or GitHub at the links below. So TFX, what brought this about? Well, TFX is a standalone CLI for Terraform Cloud and Terraform Enterprise. Now, those two platforms are, one are public hosted SaaS, and the other one is our private installed platforms. This tool, as the name might suggest, works with both. I will probably exclusively use Terraform Enterprise when referring to the platform, but there is large feature parity between the two. Obviously, Terraform Enterprise slightly more functionality because you are hosting it. But with TFX, this started back in 2021. That's when the tool, when I first started developing the tool. Since then, the latest release has about 31,000 plus downloads. So we're seeing some decent usage out there in industry, which is great. And today it has about 50 plus commands to be able to interact with. You can find it on GitHub, and there's the link there below. But let's jump into why did I build this tool? Well, selfishly, I wanted to learn Go. I'm a developer at heart. Having worked with Terraform a lot, got a little bit away from doing pure development and wanted to cut my teeth on something new. And Go seemed like a good language to learn. But second, what I found myself doing was writing a lot of bash functions and shell scripts to try to do some common tasks. It was becoming more difficult to share these, and error handling and checking. I'm not a bash wizard, so it caused me a little bit of pain. Some of these things I had actually kind of converted into Python, but ultimately I landed on Go as kind of the language that I wanted to use. Really glad that I did because it's been a good journey so far. Also, while GUIs are great, I work for an automation company. I like to work in the CLI. That's where I'm most comfortable. So a CLI made sense. Also, not everything that you can do within the platform is available in the UI. So that's another thing. But lastly, the customers that I work with and the things that I do day to day are at scale. So something that might be easy to do 1 to 10 times, it becomes really difficult when you have to do it 100 or 1,000 times, right? So with all this being said, that's why I decided to build this tool. Seemed like a functional way to learn Go and also have a real value add to the industry. Well, let's talk about what can TFX actually do. Well, the first thing that it started with was this wrap around the API-driven workflow. Now, we're not going to go too deep here, but if you're familiar with how workspaces interact with your Terraform code within Terraform Enterprise or Cloud, if I create a trust between my VCS and Terraform Enterprise, some of these things kind of happen automatically for me. And while that's great, and those are really strong workflows, that technical connection isn't always possible within my customers. But also there might be some more advanced things that I want to be able to do that the API can unlock. And really what that resulted in was a lot of, like I said, bash scripts, boilerplate jobs, things like that, just calling a lot of curl commands just to do all these basic things. And so the first idea there was just to make that a little bit more seamless and to be able to handle the things that I needed to handle when executing jobs within the platform. But what I quickly identified was there were a whole lot of other things that I could do to make my job a little bit easier. And managing workspaces was one of them. Being able to, list available workspaces and get IDs around config versions and runs and states, being able to interact with variables. These are all things that I can do with TFX that you can certainly do most, if not all these things in the UI, but again, kind of becomes a little bit problematic at scale or makes things a little bit cumbersome when, you have to do it multiple times. Next, the private registry. This is a feature within the platform that has kind of grown over time. We can now publish modules and providers, which is really great. But interacting with them, again, if I don't have a version control system that's trusted for modules, I have to do some of these things myself via the API. Providers, that publishing workflow, there is no VCS connection available, so I have to manage those as well. So with TFX, I can kind of create and list and show and delete and download, do all those things that I want to be able to do specifically with modules and providers within the provider registry. Allows for some really nice workflows. And then again, going back to Terraform Enterprise, self-hosted, self-managed platform. HashiCorp is constantly making changes and updating features or adding features to the platform. So if I'm managing that platform, I need to update it. So I want to be able to view releases. I want to be able to download what we would call maybe an air gap binary, something that, for those systems that don't have egress out. And again, for a lot of my big customers, that's not something that's possible. I have to store everything within an air gapped environment. So this allows me easy way of being able to download those binaries. TFX can certainly do more than this, but these are kind of the high level bits that I wanted to show. And when we get into the demo, you're going to see some of these things as well. Now, okay, Tom, you've piqued my interest. TFX sounds good. How do I get started? Well, first step, go to tfx.rocks. That's where the docs are stored. Everything in here is markdown generated using a tool called mkdocs, very popular, handy markdown static website builder. A lot of really good stuff in here. Like I said, stored in the repository. Some GitHub actions that kind of trigger this, make things really nice and keeps everything nice and in sync. So that's where I would start. There's a lot of good documentation in there, and you can kind of find out more about the commands even before you download. Next, once you do have it downloaded, we need to authenticate. Obviously, we're dealing with systems that have authentication in place. With every command, we have this option that we can pass in these arguments, specifically hostname, organization, and token. This is great, but there's no fun in this, having to provide this every time. So really give you this nice, settings file equivalent option, as well as environment variables. So really what this means is I can actually, if I create a .tfx.hcl file, put it in my home directory, TFX is just going to automatically pick this up. And this actually works for any flag available in a command, not just these three for authentication. So you can create that HCL file and put it in your home directory. You can also specify it at the command line when you actually execute a command. Now for the more specific credentials, the host name, organization, and token, also available some enterprise or environment variables that you can set as well if you want to obfuscate that from the runtime and not have it, sitting in a file on disk. So the name of the game here, flexibility, right? Want to be able to allow folks to use this in any way that they can within reason and be able to authenticate cleanly and safely, right? The other thing that you would want to know before you get started here is just that basic command structure. I think this is going to be really natural. There's a lot of these nested subcommands. So everything starts at TFX, obviously. But if I'm dealing with registry commands, that's going to be the registry subcommand. So TFX registry module will be for module publishing. TFX registry provider will be for provider of publishing. The good news is any command that you have, you can add this -h argument and you can get an output similar to you're seeing here. And that'll allow you to kind of investigate what is needed to execute a subcommand and maybe what arguments are needed or what other subcommands are nested inside of it. So I think it flows fairly simply. I think it'll be real natural for most people. Now, when it goes to output, if I'm at a terminal leveraging TFX, I might want to see something like this, what I would call a table output, right? It's also going to maybe present some common configuration information about what's going on here. And I do want to highlight that there is a style guide on the docs. And you'll notice here, some of these colors actually are very intentional. So green is really representing values that are provided by the user. Now, in this case, I just wrote TFX workspace list, but my config file actually has that value. But the config file itself is this yellow color, maybe orange, depending on how you look at it. And what it does is anything that's calculated at runtime. So in this case, there's a convention where that file might live. And if it exists, I'm going to use it, which is what's happening here. And you'll notice it found one workspace. Again, I didn't know that when I ran the command. It was calculated based on the platform. Now, this is great. If I want to be able to leverage this from a terminal, this makes a lot of sense. However, like I said before, where's the fun in that, right? I fully expect this CLI to be used in, some kind of build server, some kind of automated workflow. So being able to support JSON output, very, very critical, right? So in this case, if I had --JSON to pretty much any command, not all commands work this way, but almost all of them, I'd say a solid 90% of them. What happens is it'll output, the only output that'll get, you won't get any intermediate values. It'll just give you the result and it'll be properly formatted JSON. Now here I'm using JQ, which is really just a command line utility. If you're not familiar with it, it's actually creating this kind of, prettified output here with the blue and the green and the spacing and things like that. It's not changing the format of the actual file, just presenting it a little bit differently. What it also allows me to do, and there's other tools that do this as well, is I can pull out certain values here. And this allows me to chain these commands together. So I might be able to call this, get an output, and then call another command. Could be TFX, could be something else, right? So very powerful. So JSON, that output mode is very, very much a front focus for this tool because it's expected to be leveraged within automation, right? Okay, well, with that, let's go ahead and jump into a demo. Before we go there, what I do want to highlight is I do have this Terraform Enterprise instance that is out here. This is just an ephemeral instance, nothing magic going on here. This will get deleted after this demo is over. So any tokens you see are not really going to put us at risk here. They will be retracted or revoked well before this HashiTalks occurs, right? And then here's the registry. We'll see this here in a second. So let's jump into the demo. Now, first thing that I want to do is I'm just going to run a TFX-V. So this is version 0.11, which is out there available. That's what most people are using today. And if I go ahead and run a command, in this case, I'm just going to run something simple like a TFX workspace list. So give me a list of workspaces. Now you'll notice that it's actually kind of yelling at me saying, hey, you're missing some items. Well, that's because I haven't given it any authentication yet. So what I'm going to do is I just have a quick little script here. What that's going to do is it's going to generate that .tfx.hcl file. So when I run TFX workspace list again, what's going to happen is you'll see, hey, look, using that config file. So if I click into it, you'll see here's my file. Now, again, don't get too worried about this. This token is going to be long revoked before anyone sees it here. If you want to try to attack, go ahead. Everything will be gone before you get a chance to. But here, I have a few workspaces in here just to drive some demonstration. In this case, 4. But with that HCL file created, now I can just run TFX commands. I don't have to constantly give it a token, organization, anything like that. Now, if I wanted to target a different organization, I can obviously override it the command line, or I can go back to that config file and update. But with authentication in play or completed, let's go and talk a little bit about some of the fun stuff we can do. I mentioned scale. Well, one of the things that I have done quite a bit is I need to lock all my workspaces for whatever reason. Maybe it's a maintenance thing, but locking 1,000 workspaces kind of takes a long time. So what I can do here is if I want to lock all these, I'm just going to go ahead and run TFX workspace lock all, and you'll notice here, this is relatively quick because there's only 4. I can go through here, lock all my workspaces, right? Now, if I rerun that list command, you'll see now everything's locked, right? And if I go here and run unlock all, now what I should see is I'm going to call those commands, and now everything's going to get unlocked, okay? Really simple, but this starts to show you some of the value of what's going on within the tool. And if I wanted to actually do something even a little bit more interesting, I could actually output to JSON. And let me do a JQ just to get kind of a clean look. Now you can see all the things that are being available. Some of these commands don't print everything in the table just to keep it, keep it concise. So there might be more information available there. All right. Workspace locking, not super interesting, but kind of one of those nice things to have that I use quite a bit. Let's talk about variables. So in this case, I have this workspace called test variables. And if I jump back over to Terraform Enterprise and look here, you'll notice test variables is my workspace. I have no variables, right? Nothing's in here, no fun. Well, let's go and change that. So if I click or if I query against the API, boom, hey, there's no variables in there. That's kind of what I expected. But let's go ahead and create a few variables. Now, a couple of things. One, you'll notice WS, Tommy didn't spell out workspace. var didn't spell out variable. There's some shorthand that is going on here, makes things a little bit easier to kind of type out. Certainly, you can use the full form, workspace, variable, create, all those things, right? Just one of those nice kind of quality of life things that I've added. But here, I'm going to add 3 variables this first go. These are relatively simple. You'll see my names are variable 1, 2, 3, hey, fun things. But what I've done is I've added different descriptions. I've marked one as sensitive, and I've marked the other one as an environment variable. So let me go ahead and execute all 3 of these. And you'll notice they'll kind of work in succession. Also print out some information, afterwards. Now, if I go and do this list again, you'll notice, well, there's my 3 variables. I've also included the variable IDs, which can be really helpful. So let's go back to my UI, just do a quick refresh. Look, I've got my 3 variables there. I've got my nice descriptions. Everything is good, right? Well, sometimes my variables are a little more complicated than just strings, right? So what I can also do is I can actually mark a variable in Terraform Enterprise as an HCL variable. And what that means is it's more complicated in terms of the syntax. So I have these 3 values or 3 files that are kind of common data types. Here's a list, here's a map, and then this is just a basic string. This one's not really all that exciting, but let's look at the map. If I wanted to pass this in as a value, right? Getting the escaping characters in there, kind of complicated, kind of cumbersome, certainly possible, but who's got time for that anyway, right? So what I can do here instead is I can actually pass in a file as the value, and what it'll do is it'll write that. So let me go ahead and execute these 3, and we'll see kind of what happens. So like this map one, hey, look, it's creating that, but you'll notice the value is more complicated, and you'll also notice that HCL is marked as true. So let's go ahead and list these one more time, and you'll notice, hey, look, those values are in there, right? And, my description kind of matches that. So if I go back to the UI, let's do a quick refresh, you'll notice that these values are, kind of there. But I didn't have to worry about escaping, didn't have to worry about any of that kind of stuff. So for more complicated variable assignments, this is a really big quality of life feature that helps kind of write things. You don't have to worry about weird escaping and things like that. Okay. So within that, hey, creating it, giving it a workspace name, key variable, all that kind of stuff. A lot of flexibility there. Of course, when I'm done, hey, I can just go ahead and run my deletes, go ahead and clean everything up. And when I list again, now everything's gone, right? So just kind of showing you that full life cycle, nothing too crazy there, but now I'm able to interact with those workspace variables. So if I have a build step that needs to write something to a workspace variable before I kick off a run, now I have the ability to do that. Okay. All right, let's move on to kind of our plan and apply flow. Well, let's first take a look at this workspace directory, right? And you'll notice that I have this main.tf file. This is a relatively simple main.tf file. What I've done is I've required the random provider. Again, nothing too crazy. A prefix and account. And I'm using this random pet resource, which is really just going to give me a random pet name with that prefix and that number account. So I defaulted the prefix to null, so it won't have a prefix. And I've defaulted the count to 3, so it'll have 3 names. And we'll see kind of what this looks like as we run it. But that's the main.tf file that I'm running. So if I go ahead and execute my plan, so tfx plan, and I give it the workspace name, what it's going to do is, because I'm in that workspace directory, it's going to upload that, it's going to archive and upload that file, and it's going to create this run. Now, if I click into this, what you'll notice is that run was created, and this output looks very similar to what I just saw, and it's waiting and apply. So the reason why this is powerful is because within my workflow, I might need to do additional validation between plan and apply. I might send this out. I might actually need manual intervention within my pipeline or whatnot. But once I feel good about it, and I'm like, yeah, I think that's ready to go, what I can do is I can go ahead and apply that. So this would be tfx apply, and then I'm going to give it that run ID. So now what we should see is that it'll actually go through and created the apply that we just saw. And you'll see our name has 3 names in it and separated by a dash, again, no prefix. So if I go back to Terraform Enterprise, that run, you'll see that apply finished with the exact same output. So now what TFX has done for me is I'm able to, interact at the CLI level, right? And kind of do that. Now, another good thing, let's say I want to actually default my prefix to Hashi, right? So I'm updating it my default. In this case, I haven't provided it. I haven't assigned that variable, so it's not going to get overridden. Now I want to run a plan, but I want to do a speculative plan. What that means is I don't actually want to ever apply this. I just want to see what would happen if I made this change. So what happens here is it's going to force a replacement of that random pet name because it's going to regenerate. And that really has more to do with how this resource is built. And change the output, good, right? Now, if I go into this link, you'll notice that I can't apply it, right? And that's because it was a plan only, what we call a speculative plan, okay? Now, if I want to go ahead and apply that, I can just go ahead and run it again, this time without that speculative flag. And what I'll get here is similar before, 1 to create, 1 to destroy, and I'm going to get that run ID. And if I go here and go back to apply, let's go ahead and paste this in. And what we should see here is an actual apply. And now we've got our prefix, right? Our Hashi prefix, and then our three names, right? And if I want, I can go click back into here, and what I'll see is that's interesting. Let's go back here. Interesting. Might have a problem with that navigation. There it goes. Yeah, that's interesting. Little demo bug there. That's fine. All good. So let's go ahead and move on. And I can also do a dash destroy if I want to clean up after myself, but we're not going to worry about that. Okay. So now we've executed some runs. Let's look at some runs. So again, on that same workspace test, so TFX workspace list, or run list, we have this test. And you'll see these are a bunch of workspaces or a bunch of runs on this workspace that I've been using. You'll notice here that one that we just executed that was planned and finished true, or sorry, plan only was true. Again, speculative plan, right? And then we went and applied something similar, okay? Now, what I can do here though, is let's take a look at that run information. So if I can do TFX workspace run, and show that run ID, and you'll notice, I'm getting a lot of the same things, but I'm getting my config version ID, I'm getting my run ID, which I already knew, message from how it was triggered, what Terraform version, date. So again, I'm just getting information that would be very valuable to those things. Now, this is where things get real fun. What if I want to debug what is actually going on between the config version, or I want to see what config version code was actually there. I can actually come in here and let me just override this. So I'm going to grab the config version from that latest run, and I'm going to download it. And I'm going to download it into my current directory. So what we see here is it created this. And if I go and look at this main.tf, you'll notice this is that same file that I uploaded, right? Now, consider that I might be debugging a problem that I don't know how that config version got created. This can be really powerful to be able to kind of investigate what was the exact Terraform code that was executed. I can go and investigate that. So if I'm debugging a challenge or a bug or anything like that, I can maybe more clearly see what's going on. So I use this a lot. This is very, very powerful when you're trying to diagnose a problem. Okay. And yeah. Okay. So with that, let's take a look at the registry modules. So I'm going to go here, and actually, I already have this one out here. So what I'm going to do is actually, I'm going to delete this module so we can start fresh. So stand by here. Okay. All right. So let's try this again. We have no modules out there in the registry. If I come back over here to the registry and refresh, you'll notice there are no modules in that registry. So what I want to be able to do here is I'm going to create a module. I'm going to call it TLS private. So let me go back over here, and I have a module that I've downloaded. This is actually available on my GitHub as well. But this creates a private CA and a certificate based on that CA, leveraging the TLS Terraform provider. So pretty simple stuff. I use this a lot just so I can generate keys that are like production, so I can get them into place, and then obviously have a much more robust process for generating these certs in production. But typical module has some Terraform files, has my outputs, has my variables, has all the kind of basic stuff that you would expect in a module. So let's go ahead and create that module. In this case, I've given it the name TLS-private. Now, when I publish a module, I also have to give it a provider name. And usually we pick the primary provider leveraged within the platform, or the module rather, in this case, TLS. So go ahead and create that. And, I'm getting some information about it, nothing too exciting. But if I go back out here and refresh, what you're going to see is that it did create it, but I haven't published anything yet. And that's because the module and the module version are distinctly different. And that's okay, because I only create the module once, but I want to publish multiple versions. So if I, run registry module version list, right, you'll notice there's no versions because I just created it, right? So let's go ahead and create that first one. So in this case, I'm going to create it. Name and provider is the same. My directory, though, is this TLS private. So you'll notice I have this TLS private folder. It's actually listed right here. And I'm going to give it version 001. So I'm going to go ahead and create this. Now, this happened really, really fast because this is a very small module. There's not a lot going on here. You can imagine this could be quite large depending on how big your module is, but it happened relatively quickly. And if I jump back over here and refresh, actually, it was already there. 001 was published. And you'll notice that, hey, I've got HashiTalks 2023 here, inputs, outputs, resources, everybody's happy, right? Now, if I go back and list my versions, you'll see versions are good. Now, the reason why this OK status is important is because you can create that version if you didn't upload properly. It could cause some problems. So that status will tell you if things are looking good. In this case, they are. And then what I can do here, and just to kind of show you that things are real, let's say update live, right? I'm just going to update the README. It doesn't really change anything, but I just want to demonstrate. So I'm going to rerun that same command, except now I'm going to do version 002. Go ahead and run it. Again, lightning fast, right? Let me go and list. Now I have 2 versions. But when I come back here and I refresh, I have version 2, but you'll notice that the update live is now there in that README. So just kind of showing you, look, I can actually show that that version was published, and it was published directly. So no tricks there. All right. One last quick one is the TFE releases. So let me just bump up a directory here. So if I list this, run this list command for TFE releases, it's going to go out and it's going to check these things. Now, one quick note, check the docs here, but the authentication for this is different. This isn't actually reaching out to Terraform Enterprise. This is actually reaching out to Replicated, which is what stores those binaries. Okay. So I'm doing a list here. And what I want to do is, hey, let's just look at a release 675. I can go and do a show. What's really cool here is it's actually going to go grab the release notes, but you also see kind of, hey, when was it released? Is it required? We have kind of a special label that we use, and you can kind of see those things, right? And where I like to demonstrate the flexibility with that JSON is I can actually, use that JSON output, grab those release notes, and write it to a file. So let me go ahead and run this real quick. And what you'll notice is I create this file, and then now I've got kind of a markdown file that I can then, preview, and you can kind of see it in a nice rendered fashion. So again, this is helpful if I'm trying to determine, what version, if I want to upgrade, if the release notes dictate a reason to do that. I can also download that binary. This will kind of do some stuff here. I'm not going to let it download the whole way, but I can download that binary and then bring it in my environment. Okay, great. So with that, one last thing as I bring my slide deck back into clear here. What's next for TFX? Well, there's quite a bit in flight right now. We have a couple PRs out there that are pending approval, but just kind of a quick high-level bullet points, more robust testing. That's something that has been lacking for a while. Things do work relatively well, but we always like automated testing. So that's something that is really important to get added relatively soon. Sentinel management, now that, policy sets, things like that. Variable sets didn't exist when I started this tool, so now they do, so I'm going to be able to interact with them. Terraform agents, again, really powerful. Some analytics just to kind of understand how things are being used. Team management, things like that. So these are all things that are kind of on the roadmap. If you're interested in helping contribute, you can do that in 2 ways. You don't have to actually write Go code. You can go and submit a support issue. That's really helpful to me to understand on GitHub is what I mean. Help me understand what are some features that you're looking for, right? Maybe what is something that isn't working quite that well, things like that. That's really helpful. The other side of it, if you're interested in contributing, hey, I'd love to see PRs out there and, looking forward to getting more contributors to kind of make this tool even better than it is today. And yeah, looking forward to interacting with them. So GitHub issues, that's the best place to kind of reach out if you're interested in helping. So with that, that's TFX. Really appreciate everyone joining my session today. Like I said, feel free to reach out on LinkedIn or GitHub if you have any questions. And yeah, hope to see you out there. Thank you.
Solid session. Tom always knows how to make content that is interesting, how to make tools that are interesting. And when he says, TFX, if you have feedback, let me know. It will definitely be helpful. It will indeed be helpful. Check it out on tfx.rocks, which is a beautiful domain name for this. And, like Max says, it looks nice. Going to try it out. On the topic of Max Frölich, love the name. You're going to be our next speaker. I'm super excited for this session. So since we're running a little bit long.
Maths are hard. We're running a little over, so we're going to Yeah, we're going to go straight into it.
Machine learning workflows on Nomad. I'm Frölich. I work as a platform engineer at Serviceware. We take care about a lot of DevOps related topics all around the HashiCorp stack. Prior to that, I was working as a software developer in our machine learning team, where I supported our data scientists building and deploying applications to our Nomad cluster. At Serviceware, we make service for the enterprise service management. That means we provide a platform for IT, HR, finance, facility services for large enterprises. We have a very diverse tech stack from Python, Java, .NET, Go, JavaScript, you name it. And we use a lot of things from the HashiCorp universe. Many of our products produce a lot of data, and therefore, a few years ago, we set up our own machine learning team to help bring more and more AI-enhanced features into our products. We do this in a close cooperation with the Technical University of Darmstadt. So, machine learning compared to classical programming, where in classical programming, a developer writes an explicit algorithm to solve a problem. That works for a certain amount of inputs. Let's say I only want to calculate the real estate price, and I take the rooms and the size in account. So that kind of works. But as soon the amount of inputs increase, that approach doesn't scale anymore. Therefore, machine learning, on the other hand, is where a developer feeds a program enough samples so it tries to figure out the algorithm by its own. The downside of this, that the results from those models are hard to explain, and also computing those models is very resource intensive. So in machine learning, we talk about these models. What are they? Very oversimplified, you could say they are just a function where you put in all the input parameters, and then every of those parameters is multiplied by a certain variable and then summed up. These variables are also called weights and are learned during the training while you feed your program those examples. Usually that's not a linear function, and those are very, very large matrix multiplications. In our team, we dealt with natural language processing. That's the topic where we try to teach a machine how to deal with text. There are multiple examples for natural language processing. One could be sentiment analysis, where you try to figure out what is the sentiment of a certain text. Let's say movie reviews, where you say, hey, that movie was great, and you can take away, like the model computes, okay, that was a positive comment. Another example would be intent recognition, where you try to figure out what the user wants. Let's say somebody writes, hey, I moved to New York and need to update my account. Therefore, you know, he wants to change his address, and you maybe want to guide him to the change address process. Another, I think, very popular topic right now is the generating text part, where you can use OpenAPI's GPT, for example, where you say, hey, write me a one-liner why HashiCorp's Nomad is the best choice for running machine learning workflows. And the model would go there and generate you a certain text. So from a more technical point of view, in natural language processing, it's about translating words and sentences into numbers and vectors. And then for doing that, first you have to do some text pre-processing. You have to remove unimportant words, and you have to deal with a lot of unexpected content also in your text. In our case, we had a rich text editor where we got user-generated content from. And while processing those texts, we just stumbled upon base64 encoded images, or even like embedded Office documents and HTML comments. And then there's the model training, which requires a lot of resources, especially CPU, preferably GPU, and a lot of memory. To put this a little bit into perspective, the GPT-4 model, which was recently released, contains is contains more than 1 trillion parameters. These parameters are the weights we just saw in the slide before. So a workflow, how does its general workflow look like? It starts usually with some kind of experiment phase where you try out existing models, maybe where you do some proof of concept training of your models. You try out several configuration and just try to figure out what works for you. If you found something that looks promising, you start with the actual training. In the training is the part where you then actually compute the model. And then after the training has happened, you go there and in the serving phase and start creating new predictions on new inputs you haven't seen before. This usually is done via an API or something. Then when giving those feedbacks, you also start collecting feedback and try to track those for the next experiment phase. So now that we're all experts and expert scientists, let's first focus more on the training and serving part. In the training part, you compute your model, and then you store it. You do this by serializing all these metrics values, these weights and biases from a matrix, from these matrix multiplications, and serialize them somehow and store them with some pre and post scripts that maybe do some cleaning up, and then also translating maybe numbers back into more actual business functionalities. Then in the serving phase, you take those models and you deploy them with an API, maybe something REST-ish, where you say, hey, I have here my get endpoint, my get predict endpoint, where you pass them some inputs, parameters, and then you get some JSON back. In this case, for example, let's say, hey, the intent is change address, and we are 99% sure that this is what the user actually wants. So how did we start? What was our first approach? That was a very naive one, where we said like, hey, okay, let's just build an all-in-one application where the application holds all the data. It decides when to train and retrain a model, and it provides the API to serve new predictions. Also, alongside that, we have some small admin API where we manage our data and do just basic operations on the application itself. To store all that, we used for the regular data, we used a Postgres database, and we stored the computed models in a S3 bucket. How would this look like from a Nomad jobs perspective? It's just one simple job file where you have like one group with one application in there that holds all the that one container. And you can see already that this it takes a lot of resources in here when you look at the resources block. So this is actually a problem because especially the training requires a lot of resources, and the serving, on the other hand, should be redundant. So this really doesn't scale. So our next approach was splitting up the training and the serving application. So we can say, hey, okay, the training application gets more memory, and we could theoretically, if we would have a GPU, we could decide, okay, we maybe need like really fast servings, therefore we give the serving application the GPU, or you could give the training because you want to have like fast computed models, give that the GPU. So you can do more efficient resource assignment here. The Nomad job file, just split it up here. You can see first we have the training group, and that still takes a lot of memory. But on the serving, which is now, we can already set the count to 3. So we can scale this application and deploy it high available. And this one just takes less memory. There's still a problem that you have some application deployed, which is most of the time actually idle, but still allocates a lot of resources. So the quick hack we did was use memory hard limit of the Docker config. So this allows us to limit in the resources block, actually reduce the amount of memory and tell the orchestrator, hey, okay, that application doesn't need that much memory. But if it needs to do a training, it can go up to 32 gigabytes. this at least helps you to free up unused memory in the idle state, but you still have a new problem if that allocation is hosted on a Nomad client that is already at max capacity when it comes to memory. Your application potentially may crash, and you want to avoid out of memory exceptions. So the third approach we took was a more Nomad cloud native approach. So therefore we said, okay, the training task, as long as it doesn't do anything, it doesn't run at all, but we can define this training task as a batch job. Therefore, our admin part of the application decides when to trigger training by going to the Nomad API and tell it that it should dispatch one new training job. And this training job runs and it completes successfully. All the resources are completely freed again. So let's have a look here at how does this job look like. I just focus here on the training job because this is now not a service anymore, but this is of type batch. And the nice thing also about batch job is that you can register them. They don't use any memory while they're not in use, and you can even parameterize them. So when the admin application decides to run one training job, it can pass a load parameters that are then realized as a file in the allocation. So here, in this case, our training params JSON is in the end a file our training code can pick up and read parameters from it for that particular training. Just some words on advice here. Have something that limits the amount of parallel trainings you can do, because you might have a user somewhere in the UI that clicks 10 times in a row the training button, and if enough resources are on your cluster available, Nomad will just go there and say, okay, I'm going to run as many batch jobs as you like in parallel. And also, the admin application, since it talks to the Nomad API itself, make sure you limit its access by using HCL tokens. Okay. Now we are running and serving our models already in production and generating great business value. And now we collected also some feedback, maybe some thumbs up, some down buttons, or you have integrated some very smart analytics script that collect a lot of information on the given predictions of your servings. The data scientists are quite eager to get their hands on the feedback and try them, especially in combination with the data, try out if they can optimize the model and see how they can build it better and even more precise. Unfortunately, we had problems there. It is not that easy to do, just to go there and experiment. Accessing the data from outside the cluster is hard. You have firewalls in between. You have hopefully no hard-coded credentials. Also, for privacy reasons, you're maybe not allowed to transfer the data out of the data center. And storing those data on local machines. There's something called the Jupyter Notebooks, which is like a web-based interactive Python environment. It's a very commonly used tool for data scientists. It lets you visualize data. You can do all kind of interactive elements there, and you simply can program Python there. And you can run these applications inside your cluster, so it's quite close to your data. Still, in our case at least, we had some problems here. We had just like one big notebook instance running somewhere, and it was hard to figure out who is allowed to do which experiment and when, who installed which Python package, and yeah, in general, the access control was a bit tricky. Therefore, there's also a solution. It's called the Jupyter Hub, which is a multi-notebook server. Jupyter Hub itself acts as an application that spawns up and manages Jupyter notebooks for you. So every user who logs into the Jupyter Hub gets its own notebook, and therefore you don't have any conflicts, and you can do even better resource sharing. How does Nomad come here into play? we built our own Jupyter Hub Nomad spawner, which then for each Nomad job you're going to, for each Jupyter notebook instance you're going to start, it realizes those as a isolated Nomad job. So very basic overview here. The user logs into the Jupyter Hub with the Nomad spawner installed. The Nomad spawner goes to the Nomad API, schedules an isolated notebook via Nomad, and then it's data science time. So I want to give you a little demo on that. The first thing I'm going to do is start up my Nomad agent in dev mode. Everything worked fine. I should see the Nomad UI right here, and it looks promising. So in the next step, I'm going to apply this Jupyter Hub job I have here with my Nomad spawner image here and some configuration. I do this via Terraform. And now we should see some job coming up here. We see the Jupyter Hub spawning. There's Jupyter Hubs itself running. We can see it here. And if I open that up in a new tab, I get prompted some login UI. This UI is just a dummy demo UI for logins. You can easily exchange that for any kind of OIDC, OAuth authorization server login. I'm going to log in now as Max. And now I see my server options I have. So the first thing I can do is select the base image, the base Docker image my notebook runs into. I could customize this with any kind of Jupyter notebook I like. Could theoretically install some things if I like first in the image and have that pre-bundled. Then I can select the data center. I could select the memory amount I need. And then I'm going to start. So while this is starting here and coming up, we see in the Nomad jobs that there's a new Jupyter Hub notebook job running. And now it's data science time. So the first thing I obviously do, since everyone likes OpenAI, I'm going to install the OpenAI client. You see it connects and download things from for Python. As a next thing, I want to see if it worked. I'm going to OpenAI to import the OpenAI model. That seemed also to work. So now I want to get back to the example from my initial slides where I said like, hey, let's write a one-liner why HashiCorp's Nomad is the best choice for running machine learning workflows. And since I want to spice things a little bit up, I tell it to make it like a funny over-the-top commercial. With this message, I'm going to call the Nomad API directly, the OpenAI API directly, and tell them, hey, here's a message, please create a completion for that. And I pass in that message from up here. That seemed to have worked. And now we're really eager to figure out what's inside the reply. Therefore, I'm going to read the reply, the actual message somewhere a little bit hidden in this structure, but it should work. And now we print the reply. And here you see, if this doesn't convince you to use HashiCorp's Nomad as for your next machine learning projects, what else could? We can easily rerun this again. Just re-execute that cell, for example, and just do another one. So that's great. For any of you who may have used OpenAI, the OpenAI client already, you may ask, why does this actually work? Isn't there like an OpenAI API key I should use? or I need to set it somewhere, and there actually is. So if I go here and say, and look at the environment variables, you see, grab OpenAI, you see an OpenAI API key, which I hopefully have revoked by the end of that demo. But where does that one come from? And the hint, it's not baked into the image itself. But here, when I was doing my initial Terraform apply, I also provisioned an OpenAI API key as a Nomad variable, which you see here is also present. And then I can, what I did in my Nomad Jupyter Hub configuration here was I can easily modify the job template the spawner uses to provision any kind of environment variables or files via using Nomad's template block. Render any kind of things I have either as a Nomad variable, or I could use a vault secret or something from console, and I can just easily customize anything I like here. So now that I'm happy with my experiments, I go back to the hub control, and if I'm going to stop my server, and immediately in the jobs you see it deletes and stops my Jupyter notebook, and it's not there anymore. So back to the Jupyter Hub, there are more pre-built features in there. For example, you have memory and CPU resource limits you can already configure in the options. You can set vault policies based on the user that logs in your Nomad spawner job file. There's even basic support for CSI and host volumes. And as said, the Nomad job is completely customizable via Jinja templates from Python. It allows you to control whatever goes into that job. Let's say you just read about Nomad's 1.6 feature of that the node pool feature. So we say, hey, it's quite cool that all my Jupyter notebooks now can run also only on my GPU node pools. You can put this into your template. Or as said, like the very mighty template block feature, where you can just provision any kind of secrets, for example, use vault, use console, and so on. So ideas and feedback welcome. Check out the repository. But there are more challenges in the in machine learning workflows. One, for example, is load balancing, where you say, hey, okay, I have different models in production. How do I load balance between them in a smart way? How do I set up generic training pipelines? Also the topic of ETLs there. How do I do the tracking of models, and how do I collect the feedback? And there are a lot of more topics from the MLOps world. If you're more interested in MLOps, I can recommend ml-ops.org, where you find introductions in all the different topics. Also, the CD Foundation has its own MLOps special interest group. And there's also a great landscape from the Linux Foundation for AI and Data, where you can see a great selection of tools all living in that ecosystem. That looks like that, by the way. And our small Jupyter notebook is down here and mentioned as well. A lot of these products have something cloud native, usually Kubernetes flavored things on the wrapper. Therefore, some final words. Nomad has an API too. There's a lot of white space to claim for the MLOps topics in Nomad. Go hacking. Thank you.
So much great stuff in there.
I know.
So many great calls. I love the one-liners. I think I've got at least 2 new t-shirt ideas. The rocket fuel of computing. I think that's just going to work really well.
I learned a lot. It's been a while since I've worked with data, anything related to data. And I think that it was a nice reminder that there's a lot of nuance into compute, right? Setting up compute for data. But it was also, I was going to produce a bingo card and I didn't distribute it. And OpenAI was in there. You had to do a bingo card, right? Whether or not I would make it in there. But I appreciate it did.
It certainly did. But the thing that didn't make it in there is a valid key. Max has already revoked his key. I may have tried, and that's okay. We appreciate it. Thank you so much for at least showing it on screen so we know what format to expect next time. With that, we're up for our next speaker.
Yeah, yes, we are. So Justin is going to talk a little bit about Terraform provider contributions, do's and don'ts for success. So a big theme today is how do you contribute to a Terraform provider? But I think this applies to any provider that you're looking at. A lot of them follow a very similar format because they're using the SDK for development. But more importantly, it's good to recognize some important norms that we should follow, especially when we work within a provider code base. So I'm really excited to hear about some of these patterns.
This is going to be a fun session.
Do's and don'ts for success. So by way of introduction, my name is Justin DeFrank. I'm a senior solution engineer here at HashiCorp. A little bit of my background, I've had a nearly 10-year career with a mix of sales engineering jobs, product management roles, core engineering, and even DevOps roles. I've been working on and off with Go since about 2017. Since being here at HashiCorp, I've made many small contributions to multiple Terraform providers, including the HashiCorp Cloud Platform provider and AWS. I'm also the main dev and maintainer of the Datadog Secrets plugin for HashiCorp Vault. There at the bottom is my Twitter, or X, I guess we're calling it nowadays, handle. And just a point out there, all those opinions are my own, not that there really are many there. So a little bit of background, right? We've all been there. We've had some of these thoughts before, right? We find some type of deficiency in a Terraform provider. We have the Go skills to solve it, but we want to start to tackle those problems. Maybe it's a missing resource type, could be functionality that doesn't work as expected, missing test case, something that you think might need to be there. And what we're going to do actually is the next few slides, we're going to outline some core steps that you can take in order to be successful when contributing to Terraform providers. So the first thing you should look to do is really understand the code repo, and then also within those code repos, the different contribution and developer guides. There's probably going to be a lot of small caveats that need to be addressed, or some type of checklist that's required to complete. Now, when we look at the different repos, there are probably many different forms of contribution guides you've seen before, and some might live within the repo. Some are going to be links inside the repository that might take you elsewhere. Those sites might be hosted elsewhere. Ultimately, what it comes down to is try to do your best and find and understand the entire contribution guide and as it's laid out. You're also going to want to follow the code of conduct with regards to contributions. And if one doesn't exist, right, then put your best foot forward. And ultimately, what we mean here is being inclusive, having neutral tone, neutral type, and ultimately a good template to follow here is the HashiCorp community guidelines, which you can find in most of the HashiCorp repositories. So you're going to want to follow the style too. So when you're writing your contributions, you're going to want to make sure that you're matching the style of the code that's in each of the different repositories for the different providers. So we've got two examples, and it's on two different slides. That way it's not an eye chart. But this is code from the Boundary Terraform provider for creating a scope. Right, now, two things to notice before we move on. Right, number one, there's a lack of custom timeouts for this resource, and you can see where that would live under schema.resource. It would be somewhere in that top section there. And another thing to call out here is the strings in the string to schema.schema map are either global constants or constants that are defined in this local resource specified file. So on the previous slide, we looked a little bit of code for a boundary Terraform provider for creating a scope. Here's code for the HashiCorp cloud platform provider for creating a boundary cluster itself. Now, between the previous slide and this slide, there are subtle differences in the style of each of these resources or resource definitions. When we look at the HCP provider boundary cluster resource here, it's got non-default timeouts defined. You can see here towards the bottom of the top section, whereas the boundary scope resource has global and local constants defined for the strings and the string to schema map, while the boundary cluster resource here uses inline strings. So just these little subtle differences to look out for when you're working through, making your contributions, just making sure that you're maintaining that style. And this is really important to follow the style as closely as possible, because it makes it easier at the end of the day for folks who work with this code day in and day out to review pull requests, and enables ultimately that consistent development experience. So that way, somebody who checks the code out next after you make your contributions, it'll all look very streamlined. So testing. And this is much more of a kind of overarching Go concept, right? But within the providers themselves, we also do want to make sure that we're testing everything that's being executed. And taking a step back, why do we test? So we always want to ensure that the outcomes from initial code writing or even an incremental change to the code base are what we're expecting. There's going to be a general flow to tests that already exist within the repository. You should ultimately do your best to follow that flow and not introduce any additional complexity if unnecessary. Things like additional modules or kind of big rewrites, just generally unwelcomed. At a bare minimum, you should mock up or I guess take a step back, looking at actually writing some of these tests, you should start to mock up the HCL config of your resource, if you're adding a resource in this case, and check the functionality with regards to required parameters, right? That seems like some table stakes stuff, but a lot of the time people forget to do that. One thing to note, the Terraform SDK contains helper modules that can simplify the creation of tests. And a lot of the times they're in use in several of the Terraform providers already. So you can reference those within the repositories that you're working inside. And then if all else fails, right, when in doubt, ask for help. So create a work in progress pull request, submit that, and then ask for some help in the comments. And then the folks that maintain those providers will get back to you. And lastly here, just want to talk a little bit about integration tests. So some of the larger Terraform provider repositories are configured with CI/CD pipelines to build tests, do a lot of those automated functions. And what they're ultimately doing is running these integration tests at some point in the CI/CD pipeline to the systems that they're interacting with. Maybe it's AWS or GCP, Azure, Cockroach, MongoDB, you name it. So what you're going to want to do is really just do your best not to introduce any breaking changes, but keep an eye on any CI/CD automation. I'm thinking GitHub Actions, for example. Right? You want to make sure you check back in your pull requests, especially when you submit it. Make sure that any changes that you've committed in there, anything, keep your eyes open for anything that looks out of place. Right? It might be a failed CI/CD pipeline or anything like that. So just wanted to say thanks. I know this was kind of a lightning session, but thanks for watching and happy coding.
The package might say Terraform, but this really applies to literally every open source project. If you contribute, build tests, write tests, fix other people's tests if you can, if you have the ability to do that, be a good citizen in those repositories. This is all important work.
Yeah, definitely. And it makes it a lot easier for contributors to get their PRs merged, as well as the maintainers to review too, right? So it helps streamline the process for everybody.
100% does. So our next speaker also talks on the topic of testing with Terraform specifically. Ramesh, you're up.
In today's session, we would look at the evolution of infrastructure as a code and its current state, how to perform testing for deployments and provisioning on infrastructure as code using Terraform, and then further deep dive into some behavioral driven design testing using some common frameworks for infrastructure provisioning. A quick introduction about myself. My name is Ramesh Mathikumar. I'm a senior DevOps consultant with the Global Financial Services practice based out here in London for AWS. I work with financial services customers and help them move the needle towards faster cloud adaptation. So if you have to look at what's been happening in the area of automation, especially around infrastructure provisioning, you'd have to roll it back a few years to see how we, as in like most of the customers, were provisioning infrastructure. So most of the provisioning was manual or kind of, I would say, semi-automated with set of bash scripts or other type of automation available. And then once provision, there will be some kind of a manual or again a semi-automated configuration which goes to the form of service. And that's how it was for a long time. And then that gave birth to infrastructure as a code. And we have some really cool tools like Terraform, CloudFormation, CDKs, and so on and so forth, and a lot of configuration management tools as well. So currently where we are today, okay, the infrastructure as code practice has been pretty mature. Most customers we speak to have some shape and form use automated provisioning, okay, and deployments. So it's a great place to be. What does this mean for the next stage? Okay, so where do customers want to be moving towards to? So that leads to the state which where people who are from the current state, okay, where they want to move to, which is like basically some kind of an orchestration, which is available to orchestrate or choreograph the various infrastructure as code provisioning. Okay, so remember, like we already have automation available via infrastructure as code. So this part is about like being able to pull various elements of it together and then provision it. Okay, manage dependencies and so on and so forth. And then once they are provisioned, then validate some kind of validation. Okay, using some automation engineering to validate that it meets the requirements, architecture, design, etc. And then finally, right, some kind of automation to configure what has been provisioned in and manage it in an automated manner. So this is the state most customers would like to go. Okay, and today we would zoom into the automation engineering, the test engineering part of it, and see how we can apply some of the frameworks to help to achieve the validation part of what we are deploying. So when we look at when we look at the standard life cycle of provisioning, okay, so every one of us would have gone through this life cycle at some stage of provisioning. So we would have some kind of a requirement for which we would construct a module or a set of modules which would go and deliver a set of functionality. Those modules are your a code or HCL configs to say, okay, and it could be for anything. And then those modules can be hardened using some kind of unit testing. Mentioned Terra test here. We'll look at a couple of options later. So this hardening will help us give good confidence about code coverage and that the code can stand up and deliver when it's called for. And then once it's gone through the hardening through whatever cycles, right, customers might have, it ends up in a controlled repository. Okay, so the TFE registry is a good place, but then you can have your own registries as well, right, where the source control is very, very efficient, right, and you are able to pull one or multiple versions of the modules. So the life cycle then goes through, like, you are able to pull a version of this module and many such modules, concord it all together, and then go for a deployment, and each deployment would serve a particular business requirement and the architecture associated with that and the design associated with it as well. Once you have the confirmation that it's been deployed through your various CD pipelines which you might have, then you would have to run through a set of automated testing to ensure that, like, it's fit for purpose before you could go live with it. And then you could also do some benchmarking through some non-functional testing, right, with the tools available. So this is a generic life cycle, okay, and some of us would have done all the 9 yards of it, and like most of us would have at least written some modules, right, push it onto the registry, use those modules and deploy it, and so on and so forth. So this is like something which is well aware, right? So if you now then have to zoom into testing, right, okay, of provisioning of infrastructure code using Terraform, as I mentioned in the previous slide, okay, TerraTest is a good option at a unit level. It's an open source framework. It's from Gruntworks. It's Go based. Okay, the way it operates is like it basically deploys the module which you, or the code which you want to provision, and then it could run through a series of tests, and then, like, once it does, right, it destroys all the resources. So you should have some kind of a sandbox where you could deploy and, you know, erase your deployment. So that's a prerequisite for running this. If you don't want to use a sandbox and go into the complexity of provisioning and deprovisioning, etc., right, you could also use Terraform's native HCL commands to perform most of the stuff which you can do with TerraTest. So you could use something like Terraform checks, which is available from Terraform version 1.5 onwards. You can use custom conditions. You can use resource pre and post conditions to effectively validate the config. Again, as I said, right, the idea is, if you have a module, like, ensure that that there's 100% code coverage and the module can stand and deliver, right, when it's called upon. Right. So that's the first part. The second part is like post deployment. Okay, what are the frameworks available to us? So Cucumber is one framework. It's a behavioral driven design framework. It's pretty common across automated testing in the industry today. Okay, and what it is like, it helps you write your test cases in a English like format, okay, which is called Gherkin. And this Cucumber framework is supported by many programming languages. There are many packages in Python which supports it, Java supports it, many languages supports BDD style using Cucumber. So you could basically kind of inculcate the Cucumber framework within some of the programming languages which your estate is used to, and then write effective tests, which we will see down the line, right, how to do some of them and validate your infrastructure, right? And then for the non-functional side of it, like, again, there are many tools available from an AWS side. You could use the fault injection simulator to do the resiliency and reliability tests for non-functional testing. We also have the resiliency hub, and then, like, if you have any platforms, you could attach the platforms, right, including EKS, and then it tells you how resilient that platform is or how resilient that infrastructure is. So we got some couple of cool tools to help you with the non-functional side of things as well. Right. Okay. So a quick deep dive into Terraform testing. Okay, especially at the unit level. As I said, the TerraTest is a framework which is available. Okay, open source, and some of the patterns which like I have used, which I'm sharing, is like one of the first things I would do is like code coverage. Okay, so if I have like say provisioning, resources for a module, then I would ensure that those resources are provisioned and they are basically right. Okay, if I pass the right parameters, then those resources are available and then they are in the right status and so on and so forth. I could extend it further by going and looking at whether they are provisioned with the right config. Okay, for example, here's a DynamoDB table, which I'm basically like checking whether the DynamoDB table is active. Okay, the table status is active, and then my schema in which I define, right, matches my expected schema. So that's something which I can do over and above the code coverage. You could extend it to do some verification. Here I'm basically checking whether a subnet is public or private. Okay, and then like basically if I have designated subnets to be in the private, but it's appearing in the public subnet, right? Obviously, I'm going to cut short the test, right, and see how I can validate it. And then the final thing is like you could stage all of these testing in parallel or in sequence, okay, and then you can easily orchestrate it. One thing to remember is like you might need a sandbox or an actual account to deploy this, okay, and once you deploy this, right, you have syntax in TerraTest which basically destroys it at the end. Okay, so that's something which is available to us. And if you have to perform something similar in using using Terraform, the Terraform HCL has functions which supports it. As I said, right, you could use post conditions, pre-conditions, and other things. One of the things I want to concentrate today is the newly introduced check block, which, in my opinion, right, further enhances Terraform's capabilities to the testing side. So in the example on the left, I am basically calling a module, okay, or let's say I'm deploying a module, and then like I'm basically checking if the output from the module is what I would expect it to, right? Here, like I'm seeing if my certificate is in a issued status. And then if you can see, right, there's a warning which is telling me that the block assertion failed. And if you look at what I'm doing, right, I'm kind of checking for incorrect status. My status which I'm checking is issued 9 as against issued. Okay, so just to demonstrate that, like, you could extend it to check things in the right shape and form, and then like if they fail, you could use the pipeline and abort your deployment or roll it back to the previous state, right? Okay, so that's something which you can do. On the right hand side, okay, right, I'm checking a couple of data resources here. Okay, so I'm checking whether the deployment is the right account, whether the deployment is in the right region. Again, the same principles apply, right? If they fail and if you get a warning message, you could use the pipeline to effectively stop, abort, or roll back to the previous state, as it were, right? So these two frameworks, okay, would help customers to basically harden their HCL config at a unit level, right? So now what happens is like you would take these unit level modules, like basically assemble them into a deployment which delivers a business functionality, a business requirement, right, which basically matches to a corresponding architecture and design. So now what we would have to do is like validate the provisioning, right, which we have done matches to those requirements, to those architecture, and to those designs. So that's something which we need to do. Okay, like it's not good enough to basically harden the module at the unit level and then like basically not run any tests post deployments, because many things could go wrong. So we would have to continuously test it. So BDD is one good style. Okay, so here I'm giving a very basic example. Okay, so I've deployed a VPC. So all I want to know is like, hey, have I got more than 2 subnets, right, for this VPC? So what I'm saying is, given VPC ID, when I look at the number of subnets, okay, it should be greater than 2, right? So that's my Gherkin definition. It's called a feature file. So I import this feature file into a Python framework, which is called PyTest BDD. So you could see that like I'm calling the feature file as publish article.feature. Okay, and then I'm saying the same thing as what it is that VPC should have more than subnets, 2 subnets. And then I'm writing Python functions, which exactly does that, just like how the framework demands to. Okay, and I'm ensuring that there are greater than 2 or more subnets, right? Which basically means I have matched the architecture and the design requirements which that particular deployment needs. This is a very, very basic example, and you could extend it to as complex as it is. Okay, so you could use third-party packages, like say if you're applying a Kubernetes platform, you can use a Kubernetes package. If you're wanting some exhaustive test on AWS, you could use Boto3 if it is Python, right? And similar SDKs available in other languages as well. Many languages support Cucumber, as I said earlier, so you could use that that language coverage along with the packages which are available via the various SDKs which I just mentioned, and you could elaborate your testing to like you could automate anything end to end. All right. The objective is this. So, given you have deployed a particular business functionality by concording all these modules together, we should be able to independently validate whether it fits the requirement, architecture, and design, right? And then inform us back via some reporting that it is fit for purpose, so that like it gives the business the confidence as we move to more higher levels, right? In terms of like you move towards your UAT and production and so on and so forth, right? And in UAT and production, you can actually reduce the number of tests. Like you can run smoke test at UAT, and then in production you can run some sanity tests, and then ensure that like it's fit for purpose. So just to summarize, okay, we saw some of the how we evolved into the infrastructure as code framework today, and how things are automated. And from there, we quickly looked at a couple of frameworks, one at a unit level and one at post-deployment level. So I would strongly encourage you to look at these frameworks and inculcate this into your pipelines. And if you have any questions, feel free to reach out to me. Many, many thanks for attending my session. Thank you. Bye.
Thanks, Ramesh. That was awesome. Testing Terraform is one of my favorite things to talk about in general. Actually, testing overall. So this is it's a nice overview of things. So we're closing out today. We're getting to the last session. But before we get to the last session, we do have to announce the winners of today's giveaway. We announced the winners of yesterday's giveaway, but today we have other winners. These winners entered onto a form for a complimentary pass to HashiConf or 3 discounted passes. So, Kareem, would you like to announce the winners?
Absolutely. I'm super excited that Vamshi Golapalli from Chicago won our complimentary pass. Connor Brown, Jose Carlos Marco, and Josh Bolt won one of the discounted passes. Check your email for all the details. We'll be in touch with the email address that you've submitted in the form. Thank you for taking part. If you're in the chat, let us know. Hope to see you there. Same offer as before. If you spot us, let's take a picture together. This has the potential to be super fun or awkward, depending on how we go about this.
All right. On that note, we have our final speaker for today. We have some excitement from those who won. Thank you for staying on so long and for tuning into HashiTalks Build. We have our last speaker, Chris Ayers, and he'll be talking about securely developing Terraform. Oh my gosh, I need another coffee right now.
Ayers, and today we're going to talk about securely deploying infrastructure as code, and we're going to leverage Terraform and a bunch of open source tools. like I said, my name's Chris. I'm a senior customer engineer at Microsoft. I work on the fast track for Azure team, so I'm part of Azure engineering. You can, follow me or reach out on Twitter or X, Mastodon, LinkedIn. I have a blog where I actually have a blog series about some of this content. And all of my source code, all of my slides, all of my demos, they're all out on GitHub under Code Bytes. So let's go over our agenda for today. Today, we're going to talk about what is infrastructure as code, just kind of at a high level, just to refresh things. We're going to go into security tooling, what we could do with it, what are rules and customizations, how we can integrate it into our workflow, and those integration points like pre-commit hooks, VS Code, extensions, and then GitHub Actions. So we'll have a fun time, and I got a few bonus topics at the end if we have enough time. So what is infrastructure as code? At a high level, it's just a way to manage and provision infrastructure resources using configuration files and automation tools. And I work on Azure, so I have resource groups drawn here. One of the goals of this, I think, one of the best ways is to make it easier to deploy and manage our infrastructure. We make it repeatable. So we can define some infrastructure, we can stamp it out multiple times, like into different resource groups, through environments like Dev QA Prod. We can reduce the risk of our errors that we might do by manually going out to a portal or manually running commands where we could mistype something. We can have it in code. And one of the things I usually bump into when I'm trying to define and create infrastructure and solutions is security and compliance. Many industries have regulations that are needed that you have to follow for compliance, because there's been a lot of breaches. There's been many attacks and data leaks because, in some cases, of just misconfiguration. Maybe we just forgot a property, like requiring HTTPS. We already are building cloud solutions. We're building out architectures. We're writing infrastructure as code. We also have to be security experts to a degree, and we can leverage tooling to help relieve us of some of that burden. I mean, looking at the OWASP top 10, we're running into tons of stuff where you're getting both security misconfigurations, is like the 5th most highest thing in 2021. But you're also seeing in containerized environments like Kubernetes, you're seeing some misconfiguration of workloads, of policies, logging and monitoring. All of these things can be defined in some way by infrastructure as code. And we can leverage our tools to help take over some of that. And we see it again and again, looking at the state of cloud security report, logging, encryption, access policies, identity management, firewall rules. All these things are very easy to make a mistake on and to open a door for an attacker to get in and either disrupt the application or take data from the application. I've worked at a lot of places where we might have, 5-10 years ago, done a security review towards the end of our project and then tried to fix all the issues. But you can't do that. You can't just try to fix things when they're in production. Many cases you'll run into problems that if you caught it earlier, it would have been a quicker solve, cost a lot less. And so nowadays we really need to think about shifting left on security, having these things from our ideation, like from the very beginning. Is the architecture secure? Are these resources in a secure configuration? Even before we start talking about data and applications. Now there's a lot of tooling we can use. Just like as a developer, I do a lot of coding in a lot of languages. I'm used to having things like linters and security scanners. And so I usually like to run these because I want to catch these issues early. I don't want to put, bad code or bad configuration out there in an environment. I want to catch it on my machine if I can before I even check it in, or in a pipeline before I even try to deploy it. I want to make sure that everything I'm doing is compliant. Again, if we're in one of those industries that have a lot of regulation, like fintech or healthcare, we want to make sure we're compliant so we're not causing an issue. We have solutions out there today in a lot of cases. Not everything is greenfield. You can run these tools one time or multiple times on your current applications, and it's using industry best practices. It's using knowledge gained from multiple companies and multiple engineers at different levels. They might have some recommendations that you're not aware of, especially if security is not your full-time job. And it can help improve the security of your existing infrastructure and your existing solutions. And that's going to save a lot of time. Like I said, we're going to catch these things on your machine in the repo, in the pipeline, before we even get out to the cloud. So all of these, I think, are wins. Now, I'm used to running scanners against my code. There's usually two types. There's SAST, static application security testing, and there's DAST, which is dynamic application security testing. Usually the difference is SAST just runs on your source code. It has modules usually to understand your language, and it has rules that it looks for to see if there's a misconfiguration, if there's something that's a vulnerability, if there's a problem. If you're worked with developers, checkmarks or Sonar Cube, Sonar Source, that could be something that you've heard of or used something like that before, like a Trivy. On the dynamic side, this is where we actually build the infrastructure, build the application, deploy it, and we're running scans against the real application, like ZAP or the OWASP toolkit, where we're looking for some of those things at runtime. Now today we're really going to focus on SAST tooling, and the SAST tooling for Terraform has a few things that are a little specific to Terraform, a little specific to the problem at hand. So they can understand usually and scan HCL files. So your Terraform modules, all of the .tf files that you're writing in HCL, a lot of these SAST tools can scan that and understand that, no problem. But they can also look at your Terraform plan. So you can run a plan and then analyze that to see if after all the variables have been plugged in and substituted and all the properties and loops have been generated, you can check to see if there's a misconfiguration at that point. So some of the dynamic stuff you're doing in your HCL files might not get picked up, but you can run it against your plan and pick up some of those things. Now, we're going to look at 3 different types of tooling today. There's a couple other bonus ones. I'll mention some things, but TFSec, TerraScan, and Checkoff. Now, these integrate into your CI/CD pipeline. All of them do. They all have rules, and I'll dive into that a little bit more. They support custom rules, which I'll explain in just a moment. And a lot of the rules for TFSec and TerraScan, most of the ones provided are written in Rego, which is used by Open Policy Agent, where we're doing policy as code. It's a simple syntax. I'll cover it briefly. But TFSec also supports some JSON and YAML logic, and then Checkoff, most of them are written in Python. So I mentioned that custom rules customization. Now we can do a couple things with that. We can ignore rules. So if we're getting a lot of noise and we're just trying to focus on certain problems, we can ignore things. In most cases, it's a comment that you add, and you can even say ignore until a certain date. So if you have to, like, if you get a delay and then you have to focus on that issue, you can tell it to remind you again on a certain date and start feeling the pipeline if it hasn't been resolved. You can override rules. So if something is listed as a low priority and you want it to be a high priority or critical, you can change the prioritization of rules. So if something maybe is really high and you think it should be low, you can do that, or the other way around. You have complete control over this, and pretty much every tool that I'm going to be mentioning. And finally, you can write and add your own custom rules, and I'll show you this as well. There's a couple of options. So let's look at the tools. I'm going to start with TFSec. So TFSec is one of those SaaS tools, and it's by Aqua Security. Aqua Security has a number of tools in their suite of products. This runs great locally. This runs really well in your CI/CD platform. Like I mentioned, it does use OPA and Rego policies, but This has a VS Code extension, which is nice. So while you're working in VS Code, it can analyze that. And it does have a GitHub action out there. Now, something I want to mention. In February, it was announced that Trivy is going to be merging a lot of the logic and things of TSSec into Trivy. So Trivy is kind of their one-stop shop to configure. TFSec is very much just focused on Terraform. So if you're only doing Terraform, TFSec will do everything you need it to do. If you're looking at multiple languages and stuff, Trivy, might be able to cover your needs as well. And they use a lot of the same syntax and reporting. I have some demos of this, so I will dive in and show you TFSec. But as you can see here, it's giving you the lines of Terraform that are misconfigured. It's giving you an ID around it, links to documentation on how to resolve it. So I'll show you this and we'll dive into that. There's also Terrascan. Terrascan, kind of like Trivy, supports a lot of stuff. Like this is not only going to scan your Terraform, it'll do ARM and Bicep modules. It'll do GCP and AWS. It'll look at like Helm charts and customize Docker to even tell you if like some of your GitHub stuff is a little off. This is supported by Tenable. So Trivy and TFSec work with security. Terrascan is Tenable. They are merging this into their Nessus, premium product as well. Both of these have hundreds of rules on configuring resources from pretty much all the different providers, major cloud providers that are out there with Terraform. And finally, Checkov. And this is actually one of my favorites. This is by Bridge Crew. That it was recently acquired by Prisma Cloud. So I will show you how that documentation and how that integration works. They have an amazing VS Code extension, which I'll show you. This, like the others, pretty much supports a little bit of everything. Terraform, ARM, Bicep, CloudFormation, Kubernetes, Docker. All these are pretty awesome. I'm going to show you all of them. And just as a bonus, kind of some nice things that help you with your security. Your is a really nice tool that works with your Terraform to help automate tagging. So you can, I've got an image here on the screen. So you can automate your tagging around like what the Git org it came from and repo and what commit number and the last time you modified a resource. So we can tag all of those things just based on things in your Git repo. It's really nice and it integrates in CI/CD. And the other one I want to mention is Atlantis. You do have to run this on a compute somewhere, so like a VM or a cluster outside of your normal like GitHub Actions or DevOps or whatever that might be. But it'll monitor your Git repo and it'll automatically run a plan when you open a PR, and it'll lock the resources essentially. So you can only do one plan at a time. And so it will help you prevent having 2 or 3 people merging PRs around the same time or doing PRs around the same time and having plans kind of step on each other and having a couple of issues there. And so this is a really nice tool that integrates well with your workflow. Now, I'm talking about multiple tools because you can do defense in depth. Like these are independent tools. They can scan the HCL or the plan, the interpreted HCL. In some cases, you're going to get different rules. You're going to get different alerts. You could have better compliance. You could also just have a lot of stuff going on. So all of these are valid options. Now, how I integrate these into my workflow, there's 3 ways, usually. Pre-commit hooks. So on my local machine, I can do pre-commit hooks, which are awesome. IDE integrations, so VS Code extensions, Visual Studio extensions, other tools that integrate it into your workflow so you're getting alerts while you're writing your Terraform. And then in the pipeline, CI/CD, so GitHub Actions, GitLab, Azure DevOps, whatever that might be, there's a lot of integrations in the pipeline that you can do. So I mentioned pre-commit hooks. If you're not used to them, if you haven't used them before, when you're working in Git, when you start committing something, there's a pre-commit hook that runs before anything happens, like before it creates the commit object or asks you for a message or saves it to the file system. Now, this framework is pretty cool. It's out there at pre-commit.com, and you can come out here. It uses Python, and you can, install it, run pre-commit, and it has this config file where you can say, hey, I want to check YAMLs. I want to make sure there's no spaces at the end of line or white spaces, and they have pre-commit hooks for checkoff, TFSec, and Terrascan. So I'll show you those, but this actually stops you from checking in insecure code on your machine before commit, which is pretty cool. Like, it never even gets to the repo, never even runs a pipeline. The second way is the IDE integration, where we want to have alerts about problems while we're editing. We want the red squiggles. We want to be able to mouse over things and get alert messages. So there's two good extensions for VS Code, TFSec and Checkoff. There's also one for Trivy. Terrascan doesn't really have an integration in VS Code. I've found they have one for their policy editor to help make policies, custom policies, but I didn't see one for alerting you on problems. So that's kind of a miss there. And I'm a big fan of dev containers. Like, make a dev container to have all your tools you need to write stuff. And there were a couple missing dev container features. I submitted PRs to create them. So there is an extension or a dev container feature for TFSec, Trivy, Terrascan, and Checkoff. So all of them have dev container features, so you can just run it on the CLI inside your dev container. And then pipelines. So in GitHub, and pretty much similarly in DevOps, there's a TFSec action, Trivy, Terrascan, and Checkoff. So you can run these things in your pipeline, and I'll show you those in a moment. So let's get to the demos. All right, so here is my repo, Secure Terraform in Azure. I've opened it in VS Code, and I've opened it inside a dev container. So I've got a dev container here with all the features, all the stuff that you can play with, and all the extensions. So as an example, if I just open a Terraform file, you can see I've got some red squiggles down here, and it's giving me some information about these. I've got a folder here with custom checks that some of them are failing, some are passing, and we're getting some different alerts. So I'm going to start with the TFSec extension. So this is TFSec. You can just find it in the extensions menu, and you can add TFSec. And we've got your little refresh thing here to run it against the workspace. Now you can bring up the command palette and look for TFSec, and you can see we've got like refreshing it, running against the workspace, and it'll go get the version if you need one. But I ran it, and I've got a medium here, and I can see down here my findings. App service authentication is activated. It does not have any authentication enabled. So looking through this, I can see I've got some stuff, but I don't have an identity. And it says it's a medium severity. Anonymous HTTP request will be accepted. And so there's a link down here from Aqua Security. So I can click on that, and it'll give me a little bit more details, some explanation, the insecure example, which is similar to mine, and then a secure example saying, hey, I should do auth settings true. So I could take this, come back to my code. I'm probably putting it in the wrong spot. Let me double check. But then I can rerun it and see if that medium error goes away. And it did. So this ran and got rid of that error for me. So now I can look at my next one. So this has web app with AD registration. Now, something we can do is there is a .tfsec folder, and I can make a config file. So I can change, like given a rule, if I want it to be critical instead of a medium. If I want to say, don't show me low, or the last thing to show me is low, let me, don't show me the low, only show me mediums. So I can use this file to have control over what I'm seeing. The other thing we can do, and I just deleted it, so I'll bring it back, is we can look at custom rules in TFSec. So we can say, I want a naming pattern for my resource groups. I'm going to give it a description and impact. I'm going to tell it which resources it affects. So this affects Azure resource groups. And I can give it a regex saying, hey, it needs to be named this certain way. Like I want it to be named a certain way. Maybe I want tags. I want to have all these things have a tag that says cost center. So now that I've defined some custom rules, I can rerun this, and we have a hi. I'm getting a warning on a deprecated app service. So this failed. I'm using app service. So instead I should use Linux web app or Windows web app. And I can have a link right here to my documentation. And this is saying, oh, this has been deprecated, use Linux or Windows. So I can do custom information on my various checks. And I can also come down here and I could define, if I wanted, some sort of Rego alert. Like, hey, if it's a key vault and its retention is less than 14 days, alert me that that's a problem. Now, Terrascan, and I can also run it TFSec. Like I can just kind of run it on the command line if I want, using that, so cost center, naming. And you can see I'm pointing at my HCL, so it's not picking up the full plan. It's not getting some of the variable substitution. The next one, again, I don't have a extension for this, Terrascan. Now, when you run scan, what it's going to do is it's going to pull all of the policies it needs from a repo, a Git repo, and it'll run through them. And you can see it's checking some of those other languages. Like I saw it's looking in my whole folder under Terraform. It's checking every CloudFormation templates. I was looking for Helm and Customize, but it found ensure logging for Key Vault is enabled. And I can, go look at that file and I don't have logging enabled. So it's warning me that's a problem. I don't like this one as much. I mean, it's good. It's great in a CLI and a CI/CD, but it doesn't integrate well with my workflow. Also, I can come over here to my Rego policies and I can define a Rego policy. So I can tell it, I have to give it a JSON file. So I want to look at key vaults and it's going to have a Rego file. This one is going to be the thing. So the JSON file has all the metadata, the severity, the descriptions, the categories, the ID. And then the Rego file that it references has all of the queries and stuff. And because these are two different tools, you'll notice the Rego is a little different. Input Azure Key Vault. This one is input Azure RM Key Vault. So it's a little different. Something to be aware of in the docs. And finally, just so that we can quickly go into it, check off. So, I have a Trivy extension. It does just like the TFSec, but I don't have, you can see I don't have a check off view. But if I look in my extensions, I did install a check off extension. What's nice about this one is it just integrates right here into your problems. So I can look at my problems and go, oh, I'm accepting HTTPS or HTTP. I'm not redirecting it. When I mouse over this, it actually pops up and gives me some information. I can see the checkoff Azure 14. I can click on the link and say open, and it's going to take me over to that Prisma Cloud documentation, like I mentioned, and I can see the ID, the information about it. I can see a build time fix. So this is going to show me how to resolve my issues in Terraform. And then a lot of cases, what I'll also see, and this one might not, but some of the other ones might, I'll see a runtime fix, and it'll show you how to go out into the portal and resolve your issues. So it'll show you both build time and runtime fixes for a lot of these. But I do there's a good description. It's telling you exactly which resources are affected and how to resolve it. and it integrates right here into my thing. I can, I can see the version down at the bottom. This also has command completion, so I can install it. I can run my scan. That'll pretty much scan everything and populate the problems area. So I can, go to my documentation. I could, if I'm wanting to try to focus on one type of file, I can just filter it. I can go work on just my HTTP issues. Double click takes me to the relevant service. So that is a lot of the tooling that's out there that, like I said, big fan of. Now, the other way I mentioned that you can work with some of these is going into, like, let me just stash these and check out. Show you this. This is real nice. So pre-commit. So when you have a pre-commit file, you just type pre-commit, you can see it's pulling in various tools, the Terrascan, Chekhov, and it's installing things that it needs to. These files live in a .precommit YAML, pre-commit config YAML, that is at the root of your repo. Now, I mentioned that, I wanted to do some basic stuff, like am I adding large files? Do I have valid YAML? Do I have a new line at my end of files? Do I have any trailing white space? Like I just saw I had some in one of these. I want to run Terrascan. I want to run Chekhov. I want to run Terraform format, validate, and tflint. So I want to run all these things. So this has initialized my environment with pre-commit. I can install the hooks, so every time I try to commit, it'll run these. I can also just run it and say on all files, and you'll notice some things. Like right now I have no modified files. You can see it's starting to fail some things, and if I scroll up, it failed trailing white space on a couple of files, including this YAML file. If I look at the bottom, there's now a new line at the bottom. It failed some various things like end of line fixes. It's running through, like I said, Terrascan and Chekhov. Like all of these are being run. This is kind of a problematic repo. I have a lot of examples, but like I said, looking at these files, you can see it's like removing white spaces. It's adding new lines. So it's running through the scans for us and letting us kind of automate that before we even check it in. Then I mentioned, like I said, we had the tooling in VS Code that was scanning all of our stuff. And then if we go look in GitHub, I will show you a couple of workflows real quick just to demonstrate all that's there. So we have all these workflows here. We have a tfsec workflow, and that pretty much just does a clone, and then it's using the Aqua Security tfsec action. And one thing I'm doing that's a little different is I'm outputting it in JUnit. A lot of enterprises use GitHub Advanced Security. It is incredible with what it can do with CodeQL. And you can use Serif files from all the other tools to kind of upload into Serif, so it's getting there on your security page. Not everyone has Advanced Security. So I was using a JUnit format with an amazing public community supported extension, published test results, and this publishes JUnit tests. So my tools are all outputting in JUnit, and that's being published into my PR. So I have tfsec, we've got Terrascan, where you can see there's a ton of options here. You can specify different things if you want Serif, if you want various folders you want it to focus on and ignore others. And then Chekhov also has a ton of various options and outputs that you can tweak and manipulate. And this is going to use the container version by default, but you can tweak all that. So let's see what this looks like up in Azure or GitHub. So I've got all these actions over here. You can see I've been making various tweaks, and we have a pull request. Like I was trying to merge in some bad code, and if I come down here, I can see because of that JUnit, the various like TFSec actions, like the pass test and failed tests. It has all the different symbols to show me if something is failed or run. And so I can come over here and I can look like, okay, Azure Storage is using a TLS, an insecure TLS version. And I can go look at the output of it. And I can get information about various failures. Now you might ask why I care about all this. Well, I mean, I can go out to Terraform and let's say storage account. Something I think that most people might not realize is, and I know a lot of people learning do this, like I can come here and just get an example storage account, and I could, let's just say, make a new folder, and paste that in there. You can see checkoff is already scanning down here at the bottom, but what we might see is we have a problem. We might not be using the latest version of TLS. This is straight out of the documentation. We are allowing public access. We maybe don't have logging turned on. We don't have encryption with keys. And so just using the samples right out of the web page, we might be inadvertently misconfiguring things. So having these run in our pipelines, being able to kind of check this stuff and see these results and see that we've had failures, it is a huge value. I want to switch gears real quick, just because short on time. Backend providers. So we all know, or understanding how much information is stored in your Terraform state is super important. If you're doing it locally, it has all of the keys and secrets to the kingdom. You want to do it in a secure manner. You don't want to just keep it on a build machine. You want to store it in a backend like Terraform Enterprise, Terraform Cloud. If you want to use in Azure, you can use an Azure storage account. You can use an S3 bucket. There's lots of different providers. There's documentation on it, both on Terraform and for us at like Terraform on Azure documentation. But you should override your backend configuration. A lot of times what I do is I have an empty backend block that's checked into the code. That way I'm not checking in my backend information so that someone would know where to go look. And in my CI/CD pipeline, I override that with environment variables. So just to show you that real quick, what that looks like, this might be a configuration. And there are people that will check it in and have the name of the storage account and the name of the resource group and the name of the container where all that information is. Or you can have that checked in and say, I want to use managed identity to log in, or OIDC. What I usually do, and I'll show you exactly what it looks like, is let me close this. I've got kind of a empty backend. Say I'm using Azure, but I don't really give it a configuration. That configuration is not defined here. What I'm doing is I'm actually passing those, and I'll show you in the workflow. I'm getting some environment variables that are secrets out of GitHub Action secrets, and I'm getting the state out of my secrets through an environment. So I'm using environment and secrets to log into Azure, and this is just making sure that these resources exist. But I check out the code, and then I do an init and I override the backend config. The storage account name is this, the container name is that, and I'm not even passing those other secrets, these other secrets. Those all come from that documentation. So if we're looking at this documentation, it will tell you, down here, a little bit farther, configuration values. It'll tell you you can be sourced from environment variables, and they tell you like what some of the values are. Like I can use host names and snapshots. I can use endpoints and subscription ID. So this is the same for most backend providers. You can come in here, you can see the environment variables, and you can pass them in your pipelines. And then you can override stuff if you need to with dash backend config and the name of the value you want to override. And then you can just format and plan and apply normally. This, I think, is huge. Just making sure it's not checked in and it's controlled by the pipeline. And the only other thing I really want to cover real quick is OIDC. We shouldn't really log in with passwords anymore if we can help it. If you've created a servants principal just to deploy, GitHub and most clouds support some sort of OIDC authentication, OpenID Connect, where Azure, AWS, GCP all trust GitHub or trust some sort of thing. And when the runner, like GitHub Actions runner or DevOps runner, tries to run, it'll go out and say, please trust me. I'm coming from GitHub. I have this web token. Do I have access? So let me just quickly show you that. So if I were to come and make an application on Azure, if I was to just kind of go to my, for Azure, go to Azure AD and go to app registrations and create one, these are, that's where I would end up. I have an app registration. And a lot of times if I do like a service principal, I might have a certificate or secrets. But with OIDC, it's federated credentials. And what's awesome about this is you can say, hey, I'm a GitHub action deploying out. I'm coming from an org. I'm coming from this repo. And then only the prod branch. If the dev branch, if the Chris's branch tries to deploy to Azure, I want it to say dev. It has to be the dev branch or it has to be the prod branch. So I can limit it entirely by the environment in GitHub that's coming. I can limit it entirely by the branch that's trying to deploy to Azure. So this is how that repo, that environment, that branch, if it's a pull request, if that tag identifies itself to Azure. And then I can say, well, this dev one only has access to my dev resources. I have a different identity somewhere else that is my prod one, and it has access to only the prod resources. So you can have really, really fine control over what has access to your cloud based upon your GitHub environment, your branch, your stuff. And so you can securely deploy out to a cloud, kind of isolating it to only the identities you care about. And with that, I want to say thank you for your time. I really appreciate it.
A lot of good learnings. I love it.
Yeah, I think we didn't really talk about security with respect to Terraform for a very long time. And now I think we're finally realizing that as we adopt Terraform more and more, there are important things that we should be building in place when we use Terraform. And there are a lot of important things that we should consider that we didn't think about before, and now we've got tooling that addresses it. So it's nice to see how all of that gets put together.
100%. On the topic of putting things together, I want to give a quick shout out. Since we've just hit the last talk, I want to give a quick shout out to all our speakers and all the people that were involved with this. So in no particular order, Welly, Justin, Chris, Anton, Anna, Albert, Daniel, Scott, Glenn, and Max.
We also have Brian, Tom, Raul, Christopher, Rotem, Ramesh. We had our fantastic MC Cole yesterday.
Yes.
So big round of applause to Cole. Big thank you for taking time to introduce everyone yesterday. Our producers, Alexandra, who produced yesterday, and Jasmine, who produced today. They're the people who you don't get to see on the stream, but they're the ones who keep it all running. And a big thank you actually to Kareem, because you started this event a while ago. I don't even remember when. And we never thought that there was a way for people to talk about building on top of the HashiCorp tools, and it's just taken off.
It's been 2 years. This is the third edition. Some of you have been here for literally all editions, and I thank you for that. Some of you are new. I thank you for joining us and spending your time with us. I know time is always scarce, so excited to have you all here. It's been an absolute pleasure. We'll have the videos up on the website. If you have no travel plans, HashiConf is coming up October 10 through 12, so you've got 2 months. We'll have a couple of today's viewers there as winners of tickets, so that's super exciting. We'll have a lot of awesome sessions, and if you can make it to San Francisco, check out our meetups on meetup.com/pro/hugs and find your local chapter.
With that, I think it's time to wrap up, right?
Think so.
Yeah, we've had a fantastic 2 days. Join us for any of the other HashiTalks that you'll find on the HashiTalks Hub. We hope to see you at HashiConf. If you are going, let us know. And big thank you to all of our speakers, MCs, and the production team. With that, have a fantastic day.
Have a good one.